Okay, hello everyone, welcome back from lunch. My name is Sarah Hutchin and I'm chairing the start of this next session on flood risk management, and in particular in relation to adaptation and resilience. I'm Senior Advisor on Freshwater Policy with Scottish Natural Heritage. I've seen them involved in the development and implementation of the Flood Risk Management Act and in the inclusion in that of consideration of natural flood management measures in flood risk management. The SNH obviously is interested in the contribution that NFM measures and green infrastructure can make to flood risk management, and also the additional benefits that they can provide for biodiversity and for creating attractive places for people to live and work. So in this session we've got two presentations on how we can manage catchments to reduce flood risk and how we can make our cities more resilient to flooding. So first we've got Professor David Balmforth, who is an Executive Technical Director at NWH. His recent work ranges from the oversight of multi-million engineering programmes to flood advisory work in UK, Singapore and New Zealand. He's also a visiting professor at Imperial College and a past president of the Institution of Civil Engineers. David, would you like to come up?
Well, thank you, Sarah, and good afternoon, everyone. Thank you for inviting me. It's a great pleasure to be here. I'm going to talk about urban flooding. And to illustrate this, the Glasgow 2002 floods. Urban flooding is a very complex process. This analysis done by Scottish Water at this particular location showed that of the flooding here on the ground and within property, 1,500 cubic metres came from local rivers, 800 cubic metres from the public sewage system, and 1,200 cubic metres directly from urban overland flow. This is rainwater that falls on the ground, never gets anywhere near a drainage system at all. It just contributes directly to flooding. And managing that complexity is very challenging. And our conventional approach to this, of course, is to try and stop this flooding from happening. So we invest ever more in large infrastructure, more sewers, bigger pipes, tunnels, storage shafts, and so on. But if we set that in the context of the future, we have to question how sustainable that approach is likely to be. So this is just a simple pie chart which looks at the flows that are generated from urban runoff for existing scenarios, for existing extreme events, and then taking into account the sort of factors that are going to influence that in the future. Growth, which is shown in red, and this is assuming that that growth goes ahead with appropriate SUDS installations as part of that growth strategy. So this is assuming that there's already some inbuilt storage into that new development. Then there's urban creep. This is the infilling of urban areas in between existing buildings without any real major development, but nevertheless it hugely contributes to runoff. And then, of course, the ever uncertain climate change prediction, which we've been talking about this morning. But what is really interesting is when you look at what might be the implication of something of the order of a 40% flow on our urban systems, then you see what was described this morning by Nick as a sensitive catchment response, because the response is by no means proportional. That 40% flow will typically generate 100% more flood volume on the surface, 130% more properties that are affected, and a 200% increase in flood damage. That's a threefold increase in flood damage by the year 2080. These are all 2080 predictions in very general terms, and we recognise the uncertainty associated with that. But what is worse is that if we carry on with our conventional approach, our solutions costs for this, our means of managing this with conventional infrastructure methods, would see costs rise for somewhere between 4 and 8 times. And just to get the uncertainty bit right, I don't think it matters whether it's 4 times or 8 times, actually. It's completely unaffordable. What this demonstrates is we simply cannot continue with our current approaches to managing urban flood risk. Now, that doesn't mean we don't have to continue to invest in conventional measures. We do need to continue to invest in storm drainage, but we have to recognise, both professionally and publicly, that there's a limit to that, and beyond that limit, flooding will occur. And it's likely to become more frequent, and it's likely to become more severe in the future. And we need collectively, as a society, to learn how to manage that flood by adaptation adaptation and resilience. So I'm going to say a little bit more now about what that might look like and pick up some examples from projects around the world. And the best way of structuring this is to recognise what is becoming much more widely accepted now as the three elements of drainage, which is a source, pathway, receptor concept. And we need to start looking differently at how we manage in those three areas. So firstly, limiting the flows that get into our drainage systems to enable them to do more work than they're currently doing. Then to recognise that flooding will occur, but instead of just leaving that to random chance, let's look at how we might manage that by creating surface pathways to manage the flows that exceed the capacity of the drainage system, to direct those to sacrificial storage areas in our urban areas where the damage from that flooding will be far less than if we just allow it to be indiscriminate. And then finally, to improve the resilience of those parts of our urban areas that get impacted by the flooding, the receptors. This will be properties, infrastructure, and so on. I'm going to give some examples of how we might do that. So let's start with that source control, limiting the flows entering the drainage system. So the first picture here on the top left, I've deliberately chosen pictures rather than graphs and numbers this afternoon. I slightly apologise for that, but I did have in mind this was the first presentation after lunch, so perhaps we make it a little lighter and less demanding from that point of view. But this is an example from Portland in Oregon. Now, in Portland in Oregon, the domestic dwellings there, which contribute a substantial amount from roof runoff to urban flooding, are fairly well spaced out. And what they did in Portland was they put in place a customer incentivisation programme. So they incentivised people to disconnect their roof areas and to drain that runoff onto the land surrounding their property so it could naturally infiltrate into the ground. Now, what is interesting about this project is that incentivisation programme, which wasn't a large financial incentive and it was supported by the formation of local self-help groups, resulted in an 80% success rate in rainwater disconnection from roofs. And that's a remarkable achievement. I think actually that project there is more important in terms of the lessons from community engagement than it is from the actual measure that was used in that particular example. Retrofitting rainwater barrels. Something I'm personally very keen on. I've done some work on this in the past. I've piloted this. Works very effectively. Of course, for storm control, these barrels need to be empty rather than full, which is why we've not called them water butts. Also, I do tend not to use the word but very much when I'm working in the Americas. It doesn't go down too well. It tends to be largely misunderstood. Project we delivered some while ago in the Netherlands on the left here is a retrofit infiltration basin. Now this takes water from an existing urban development. It's been retrofitted into a park area, so this will be covered over and regrassed afterwards. And this takes the water, it stores it in there, and then it releases it slowly through a borehole into a deep aquifer. So it also acts as an aquifer recharge system. So you're actually you're short-circuiting the water cycle locally, primarily to manage drainage, but also to act as a water resource. From an adjacent area, so that was from Delft in the Netherlands, not far down the road in The Hague. We've got this example on the right, which is source control as part of urban regeneration. So this is using the opportunity of a general conversion of what was originally an industrial area into a dwelling area, a domestic dwelling area, and the retrofitting of source control basins, small basins there, just to compensate for the acceleration of runoff that occurs when we urbanise areas. So it's to return the runoff characteristics of that area to what it would have been like before the development had taken place. So once we've addressed the source, we can now move on to the pathways. And I'm not going to talk here about enhancing the capacity of our drainage systems. What I'm going to be talking about here is how we manage those exceedance flows on the surface. Now, we know from our experience of modelling and mapping, we actually can predict pretty well now where flood water will go in urban areas. We can identify, and we can colour code if we want, as we have here, the properties that are affected. But what's really important here is working out where the flows will go, because interestingly, what we find with urban floods is that water tends to flow downhill and accumulate in low spots. So here it is in the 2002 Glasgow floods, road acting as an exceedance flood pathway. Highway engineers say to me, oh, we can't do this. No, we mustn't do this. And town planners say, we don't want to see this. I said, but you've got it already. This is not something we're expecting to happen every day. But in your really big rainstorm events, you will find that a considerable volume in urban areas is transferred like this on the surface. At relatively small depths and modest velocities, but it does convey large volumes, and it usually dumps it just where you don't want it. In this case, about half of this flow went into a leisure centre and caused a huge amount of damage. And we could have managed that, actually, if we were more creative about creating these surface flows. So here's an example from Cornwall of a road designed as a flood channel. The people of St Blaise were fed up of getting flooded by their local watercourse in extreme events. The road tended to get flooded in the same time, but basically most of the flow from the catchment went into the watercourse. It then went down a very narrow channel to the village, and it caused flooding. And it also flooded the local petrol filling station, and the owner of the petrol filling station came up with this idea of saying, well, why don't we just keep it on the road and divert it on the road around the village during these events? And the engineers, local engineers, said, OK, we'll have a go at that. And they designed this. And this is a road here which acts as a flood channel in extreme events. You can see the spillway into the watercourse downstream of the village. So now, instead of the village flooding, the road floods, but at a modest depth. Traffic's limited to 30 miles an hour. And it works remarkably, and remarkably well. On the left picture here, we see we're back to that urban regeneration in the Netherlands, and here we see a drainage where the surface water is kept entirely on the surface. There are no surface water sewers on this development. All the rainwater comes off the roof and off the surface area, and it flows into the road. And the camber goes the other way on the road. It has a channel in the bottom, and that conveys the water and under normal storm events, and then the more extreme events, it fills up. The whole of the road then acts as a flood channel, and that then can overflow into that infiltration area you see in the background there, and then that in turn can overflow into the woodland, which becomes a sacrificial flood area in the even more extreme events. And again, I've had other engineers say, well, we can't do that. We can't have the camber going the wrong way on a road, or this channel in the middle. I mean, people will trip over the channel, or what. It works fine. It's just an estate road. It's not the M8 motorway that we're talking about here. So, and then similarly, the swale from this development here, which is very effective for modest runoff, functions as a conveyance and a water treatment facility. But under extreme events, the whole of that grassed area fills up to provide a conveyance channel. But I think my favourite example of creating exceedance flow channels in urban areas is the Connswater Greenway project in East Belfast. This is a deprived community, a low-income community in East Belfast. It doesn't have much amenity, and it has what you often find in these areas, a canalised watercourse full of rubbish. And a local community group got together with the idea of creating an amenity park, a green corridor in this area, which the local residents could enjoy. And they called their first public meeting to put this idea on the table, and the local residents said, oh, so you've come to fix our flooding problem, have you? And everybody went, what flooding problem? And of course, it turned out that this watercourse was not only an eyesore, but it actually flooded. So flooding also became a driver behind this. And if you look at these two pictures, the top picture here shows the watercourse. It's on the boundary between the green area there. It's just that little ribbon. Let me just see if I can avoid the nervous shake of the pen here. And just like that, there's the Connswater Greenway. This is the estate here with fairly high unemployment, low-income families living on there. And this is the realigned waterway, meandering natural waterway. But what they've also done is between this footpath here and the boundary on this side, they've created an exceedance flood channel. So the whole of that area now can be used to convey flood water and reduce flood risk. And it's a really imaginative multiple use of the area. I'm going to come back to talk about that in a moment from the amenity and recreation point of view. Here's a very similar concept in a new development in Singapore. This is in the north-east area of Singapore, where there's a lot of new housing development going ahead. Similar watercourse here, and this is just to give an example of marking out the exceedance corridors so that people know what to expect. They know it's meant to fill up in extreme events up to the level of those markers there. So there's a management of expectation in the community. Sacrificial storage, all sorts of ways we can do this. This is two examples. The right-hand picture is from the town of Malmö in Sweden. Peter Starr, who was the chief engineer of Malmö, was a real pioneer of sustainable drainage and some of these other techniques. And at the left from a city in Brazil, and it was a big open square like this. It reminds me a little bit of George Square in Glasgow. You know, this fills up with water in times of heavy rainfall. We've not quite managed to achieve that in Glasgow yet in George Square. And it is a challenge, isn't it, for municipal authorities to actually say, we are going to deliberately flood this area in preference to this area. Don't think we've really crossed that bridge in our municipal planning in the UK just yet. And then finally, the resilience of receptors. I do some work on a regular basis in Singapore, advising on flood risk management. And Singapore have some very interesting, very simple, straightforward rules on minimum threshold levels. All new build, including infrastructure, has to have a threshold level for all entries, whether it's a ventilation tube or it's a pedestrian access, 1 metre above the level of the surrounding maximum flood level or the surrounding ground, whichever is the greatest. So the picture on the top left is a new shopping mall on Orchard Road in Singapore. The bottom picture, one of my favourites, is the entry to the metro station on Scots Road. It's the new standard design for metro stations in Singapore. Most of them are built like this now. So you actually go up a flight of steps or a ramp or a small escalator onto an entry platform, and then you go down into the metro. So in the last 3 floods, which they have had in the centre of Singapore, not only is the metro operated, it's actually operated to time. As opposed to the metro here, which was suffering rather badly in Japan, in Tokyo. This is what happens when you have a level entry to a metro system in a flood event. It's an interesting behavioural reaction from the public here. I certainly would not be taking a small child down into this metro. But this is a big worry, for example, for Transport for London, where most of the London Underground entrances are at street level. It doesn't have to be permanent. You can have rising barriers. They can be manually operated or automatic. So again, for the older shopping malls on Orchard Road in the bottom centre picture, they've fitted adaptable barriers, an automatic barrier in the top right from a building in the centre of Sheffield, and then Sheffield Meadowhall development on the left here, which has rising gates at the entry to all the external areas to protect it from flooding. Sacrificial areas don't only restrict themselves to pond areas in urban areas. We can have sacrificial floors to buildings. Ground floor, sacrificial ground floors. What other use could we use the ground floors of our buildings which weren't so vulnerable to flood water? So the concept of building on stilts, and in some areas, particularly where you have communities which have wooden homes, whole homes are propped up. I'm not suggesting that's necessarily going to win a design award on the bottom right. Indeed, I wouldn't necessarily apply a design award to any of those. They're just examples of a different way of thinking about how we design and manage our building stock to make them much more resilient to flooding. Floating homes in the Netherlands. The top picture is the classical picture many of you will have seen. The development you may not have seen, which is from Dordrecht, in the bottom picture, which I visited with some members of Parliament. That's the British Parliament, just to be clear. Last year on a fact-finding tour as part of the EFRA Select Committee inquiry. And then designed by a colleague of mine who works for Backer Architects, their can float home. We started to call these can float homes on the River Thames, of which a number of these are now under construction, and this one in particular is now finished and operates. And this goes up and down with the water level. So it has a buoyancy tank in the basement and some vertical guide rails, and the home doesn't actually float. It sits on the ground normally, but under flood conditions it rises. And so it doesn't suffer like the Dutch homes where you put the grand piano. And then the buildings themselves, improving the resilience of receptors. Temporary flood barriers, great way of retrofitting, unlikely to keep all the water out, so we also need to look at what happens within the building. In the top left picture, you see a typical reinstatement of a flooding home, putting back all of those materials that are susceptible to flood water, instead of moving towards a much more sustainable approach where we start to use water resilient materials and methods which help to manage water within buildings and stop buildings being out of action for many, many months after they are flooded. But what we find is when we start to address all of these issues from the source pathway receptor point of view, this different approach to managing flood risk, we suddenly find we open the doors to a whole load of other benefits. We find that when we start to store water at source, we can also provide features which improve the water quality. As in this development again in the Netherlands on the left, where we're using a little wetland to improve water quality, a rain garden from the Americas, retrofitted to a school on the right, and then the green roof from Malmö in Sweden, all improving the quality of the water that runs off from our areas. Scheme we've been delivering in Indianapolis, improving biodiversity as part of the flood risk management programme by using natural features. The amenity I mentioned earlier, the left-hand scheme from Malmö, was specifically designed with representatives from the local community, not just to manage flood risk, but to provide a nice place to live in. The right-hand picture shows where we now are with the Conswater Greenway project in providing a recreation facility for the people who live in that area of East Belfast. And finally, health and well-being. From Copenhagen, from Denmark, on the left, we've got this rather nice layout which uses water very much as a design feature to create this nice area in Frederiksberg. The top right-hand picture from the Netherlands, I'm not so sure we would necessarily go with some of the design detailing for the cycleway there, but nevertheless it's a different cultural approach to water. And finally, in the bottom right-hand picture, we've got the Conswater Greenway project in its finished state. And Queen's University Belfast have done a research project which demonstrates that the value of the health benefits, the reduction to the cost of the health service from that community through having this opportunity of extra recreation more than pays for the total capital cost of that scheme. So in conclusion, let me remind you that I don't think we can afford to defend against all flooding, and we need to be actually clear with society on what our ambition is there. What do we defend and what do we manage in relation to flood risk? Shifting our thinking from defence to resilience, limiting the flows entering our drainage systems, managing exceedance flows on the surface, and creating sacrificial storage areas. Making our receptors much more resilient to flood water, and perhaps above all, using those features to create a better place to live. Thank you.
Thank you, David. And our second speaker is Dr. Mark Wilkinson. Mark works at the James Hutton Institute, and his prime focus is on natural flood management.
Thank you, Sarah, and thank you for the invitation today to speak. I'm going to be trying to answer this question about how can we manage catchments to reduce flood risk. And I have to actually thank David for his talk there, because I'm going to show you some similarities about how we can manage water in rural catchments, similar to urban catchments. Introduction, like with the previous speakers, we're seeing quite a lot of floods recently, and highlighted here the aftermath of Storm Frank and the River Dee. And traditionally, we manage our flooding by traditional flood defences, flood walls, for example, like this one here in Keswick. But is this our future? Can we keep building flood walls higher? Now, I found this interesting image from the Danube, which kind of shows you we can't really keep building them higher. In fact, I would be quite scared to live in that house there. It's quite a worrying picture. We can keep building higher, but we need to look at a full range of measures. And the measures I'll be talking about today are natural-based approaches, but things like property-level protection, traditional. But we've looked at, Haley's given some examples about climate change. I want to quickly give an introduction of maybe about land use change and how our catchments have changed from the past. And this is Tarland in Aberdeenshire on the River Dee. And this is a map of it we found from 1832, and it shows it as a nice wetland system and lots of wiggly rivers and trees there and riparian planting. And then the agricultural revolution came along. Striking difference that we have basically canalise a lot of channels. We create drainage, and what you don't see on there is we intensified our agriculture. And also we built on the floodplains, which is also a risk. But we move forward 100 years and nothing much has changed. We just bury a lot of our ditches. So it's quite striking, not much has changed there, maybe a few trees more and less in places. So I'm going to look at this from two aspects really. I'm going to really spend a lot of time on this, what measures are at our disposal, how they work and where we place them, and look at, again, the integration and multiple benefits, which I think is important, and finally looking at communication, delivery and funding. Brief introduction to natural flood management. I'm not going to go into detail on this, but it's a catchment-based approach that works alongside traditional engineering approaches, and it's quite embedded in the policy, the Flood Risk Act of Scotland 2009, and that places responsibility on several government bodies to cooperate to promote NFM techniques, which is great. It's a great piece of legislation, but it's trying to take that forward and get these projects off on the ground. I'll try and show some examples here. I want to put a statement in about many terminologies, and it can cause confusion because some colleagues from south of the border might know as working with natural processes. You go over into Europe, natural water retention measures have been used. You also see things like SUDs and rural SUDs, green engineering, natural engineering, the list goes on. This capsule phrase, which we've just recently worked on a paper on, nature-based solutions, is trying to bring this all together into one terminology, but lots of jargon there, and that's just on the definition of the subject itself. Look at specific measures. We can probably have a debate about how many terms there are for a leaky barrier, large woody debris, beaver dams, beaver lodges, it goes on. There's a lot of definitions out there. So I want to try and summarise that up. Firstly, looking at the types of measures at our disposal, woodland planting, land use management, better improvement of the soil in the uplands and lowlands, river restoration techniques, and coastal, but I won't talk much about that today. In fact, I'll focus mainly on land use management and river and floodplain restoration. But 4 words to sum this up, and in fact, I'll take it down to 1 word. Slow, store, filter, and disconnect, or just basically attenuation of runoff in the landscape. But how do we do this? Well, we need to take a catchment-wide adaptation to flooding, really. And like David, I like to take management on a source, pathway, receptor approach, where our sources are really the land management itself, whether that be a farm, forest unit, the water on the landscape itself, the soil, the ditches, the small drains there. But floodwater will get to rivers, so we need to have better management of the rivers themselves, the pathways, allowing more room for the river in the appropriate places. But I'm not taking away the need for receptor management. That's key, and there's a place for that. So it's using all tools within our in our toolkit. I'm going to be looking at some local scale examples first. I'm going to use the River Dee as an example and try and use some data fresh off the press from the period of Storm Frank and afterwards to bring it in line with this meeting. I'm going to be looking at Tarland for source management and then upstream of Brainbar for pathway management and linking that to multiple benefits. And the nice thing about these two catchments is Tarland's quite an intensive arable livestock area, whilst the bit upstream of Braemar's, Cairngorm National Park's picturesque Cairngorms may not be as natural as you think when I show you some images. So firstly, this is one of my favourite images from Storm Frank because that's leading into the rivers. That is our sources generating lots of runoff. They're saturated, producing runoff, heading into the to the streams or even into the towns themselves. And these tramways, they act as a sort of a micro pathway heading down. So we need to manage these better. So in Tarland in Aberdeenshire, we've been working with the MacRoberts estate there, and we showed the concept using the GIS tool we've developed. And actually, that image maps nicely onto that left diagram there. And we proposed a way to store water coming off the field system, their 32-hectare field system, and stop it getting directly into the village. And I think we sometimes forget about that. It's not about just water going into the rivers, but actually it can go head straight into the towns themselves, the villages. There was a wetland there previously, but it was filling up with sediment. So what we did is we created a soil bund to disconnect most of the flow, store it, and the fine sediments to allow the wetland to do what it does best, have good biodiversity and nutrient reduction potential. And also looking at the soil management. I'm going to focus on the soil bund. There is engineering in that. It's we use the term natural, but actually it's more engineering, soft engineering in here, because it's got an engineered spillway. We don't want it to erode over the top. We want this to stay in. And it's got an outlet pipe to have control. And I'll show you why that's important now. Because actually, this is the Storm Frank period. First peak of Storm Frank. It's working remarkably well in Storm Frank. It fills, and it does what I really like it to do, be empty, in line with the previous talks, and David's talk, like an empty, full rain butt, it's no use. We needed to drain away to have capacity for the following event. But the issue here came after the new year, as I like to call the storm with no name. Makes you think about naming of storms. And this is the storm that affected Inverurie, Port Elphiston, the Don, and Tarland itself. The ground's completely saturated, and the pond's full. It still has a bit of attenuation, but it's not performing as well as it should, showing that we need extra storage for these types of extreme events. I should mention the cost of this. I must thank the estate because they took the cost on themselves. They saw the potential of this for soil management alone just by collecting sediments in the field. But estimate of cost of that? Hundreds, really. It's a man with a JCB, really, sort of to come along and help to construct this. So, performance throughout the year. I think this is important to highlight, and going back to Haley's point, we talk a lot about depth and duration, and sometimes we forget about intensity. So you can see it working quite nicely during the Storm Frank period at the beginning, and then it's full. And I've put soil moisture data from a nearby soil moisture site. But what is soil moisture measurement we have there in the catchment? But what you can see is this intense rainfall event in June. The soil moisture is quite dry, and we see the pond filling. So we could assume that's infiltration excess overland flow. Basically, it can't infiltrate into the soil quick enough, and it's running off. And that's quite important to manage those types of events too. So we need to design, and this is working quite nicely for that event, to capture the runoff, but also the fine sediments. These can be highly eroding events. And again, highlighting sediment risk. So it's critical to understand the antecedent conditions, manage storm depth, duration, and intensity. But most importantly, I like to highlight is the farmer can still use this field. It's dry most of the time. So that's an important point to say. Source management during extreme events. I'm going to move to riparian buffer strips here and some work of my PhD student, Lindsay McLean. And, you know, what we're showing here is the performance of riparian buffer strips during many different events, and highlighting extreme events here. But we assume riparian buffer strips just filter the runoff and act as sort of a roughening capacity. But actually what we saw in this riparian buffer strip is the micro-topography of the landscape, the plough furrow and the tram line, act as a conduit to send the water past the buffer strip to the corner of the field. And you can see photographs from the Storm Frank event. Well, actually, this was just after Storm Frank, on the 7th of January, and water's gone to the corner of the field. So I like to take a sort of a treatment train approach here. I would instantly think to put a bund in the corner of that field to collect water. So we can improve these to work better for flood management. I should mention there is, you can't see quite in the photograph there, the stream water is quite brown. It's carrying a lot of fine sediment. That's quite concerning. And one thing I'd like to highlight here is we're capturing overland flow, but a lot of water gets through subsurface drains in fields. So we need to manage this better. So one bit of work we're doing with my colleague Mark Stutter in Balreddy Farm, our research farm near Dundee, is creating eco-engineered buffer strips through this project BufferTech, working with the Danish. This is a valuable bit of land. The farmer uses 95% of the field, and we have this small little stretch of land, 10 metres wide. I've just highlighted in the last slide that it's not very effective. It has some reduction, roughening effects for runoff, but there's a lot we can do, more we can do. So what we've done here is we've broken the land drains into these storage ponds here, which can be drained down to allow to have capacity for the flood events. That allows the water to infiltrate through a bioreactive root zone of, say, willow. The farmer can use that as an energy crop, and it drains into the stream. So we're trying to maximize the multiple benefits of this important area. And this is 6 months after establishment, and you can see it's quite, like a normal buffer strip, but with some ponds in. And they help to break the subsurface flow and add storage during rain events. But just showing you some data here from last year from our nitrate sampling. The take-home message here is The nitrate is very high for this. That's quite a high concentration of nitrate. It's higher in the field drains, so that's that blue line there. And as it goes into the stream, it's lower. So there is a denitrifying effect going on here through most of the year. We should highlight is if we didn't break that up, that would have headed straight to the stream. So it's the importance of managing these subsurface flows. I'll move on now to pathway management and talk about how we can make more room for the river. Mark mentioned about the SEPA natural flood management maps. I think the floodplain maps are a great tool. They show great potential areas for floodplain storage. And actually in the Cairngorms, there's a lot of good storage on floodplains, which are doing a lot of good at the moment, but there's more that can be done. And I'm going to show you this example from the Mar-Lodge estate. It wasn't directly a flood risk management project. In fact, it's one of the multiple benefits. It was actually delivered by an integrated partnership approach, looking at other things such as biodiversity, geomorphology, and aesthetics. I'll come to that point later, because traditionally an embankment was put up here to protect the floodplain for agriculture. But as you can see here, the River Dee wants to head back to where it used to be, meandering through the floodplain. And in the 70s, it breached again. So the landowner at the time put a call out and asked for any material possible. About 35 to 45 old cars went in there. There was rumoured there was a tank in there as well, but I don't think they found a tank. But this was a lot of rubbish, and that was a problem for the Cairngorm National Park. This was a picturesque scenic route, and you could actually see these corrugated iron. And if you went closely, you could see an old tyre popping up. You have to watch out when you're at this field site. Health and safety was quite interesting. So post-restoration, it's been lowered. Then Storm Frank came along, and floodplain's doing what it should do lovely at this point, because there's no risk at this point to properties. And after, you can see actually it's lowered the flood embankment, but the river has been connecting more to the floodplain. The take-home message here is spot the difference. The river bar has now moved, and my colleague Steve Addy has been out surveying. So if we take that red line, this is a topographic cross-section. You can see the blue line there is before restoration, the embankment, and then the dotted line is a lowering of the embankment. And then post-Storm Frank, you can see it's eroded down a bit more. But the key thing is the incised nature of the channel has filled in, so the morphology is changing. Now, we need more data because we don't know if this is a natural process. It's the key thing about Chris made about we need longer data sets, the issues of natural variability. So, but you can see it's quite interesting that the geomorphology, and that's an important point, the role of geomorphology in flood risk management here as well. I just want to take home message, but I'll not say too much on that today. And here is not a very high flow event. This caused no flooding, but just showing you reconnection onto the floodplain there at this site, delivering multiple benefits. Which the project set out. Pathway management during extreme events. Well, as scale increases, so too does the amount of storage you would need to require. So natural floodplain storage might not be enough. Certainly, southern England, we're quite limited with space of where we can store water. Certainly in parts of Scotland as well, we're quite limited. So we may need to further engineer our floodplains and offline storage areas, bunded areas on floodplains or washlands. But that makes us think, well, where does this fit on the scale of natural approaches to traditional engineering? Sometimes I have a problem with natural flood management because actually the true approach of natural is leave the system alone and let it get back to normal itself. If we plant trees, we engineer. But I'm talking here about offline storage washlands probably being this middle ground. And we talk about the concept of NFM plus, trying to add further storage capacity into the system. But is it one large reservoir? This is research we're trying to look at the moment. One large reservoir we should be looking at are lots of many smaller ponds. Well, you might think from a planning perspective, that's easy, the one large reservoir. It comes with lots of legislation, such as the Reservoirs Act. But lots of smaller ponds could deliver a lot more multiple benefits shown those previous slides. So local scale processes are fairly well understood, but further research is really needed at a catchment scale to understand these issues of clusters of measures. What is the role of each individual measure? Such as if you model a leaky barrier, well, the role of the leaky barrier is to send water onto the floodplain. So the roughness has a key issue there. And synchronization, where should we be doing this? We don't want to slow down a flood peak that actually needs to be released quicker within a subcatchment. So really our knowledge is known quite well at the local scale, but the interest, of course, is at this catchment scale. And that is a key thing we need to start to address further. To add more difficulties to this is NFM measures vary with their impacts in space and time. I'll not mention too much about woodlands, but the key thing is they take a long time to establish, so their impact will take time to establish. But they generally can be applied quite widely. Of course, the effectiveness depends on a lot of other factors. But things like leaky barriers are instantly effective. Well, in a way, they're trying to speed up the natural process of wood in rivers. We engineer these to slow down water. In the example here is the first order channel in the Beaumont catchment on the Scotch borders. But the effect is spatially variable, even within the small stretch of river. So what you can actually see here is this is a survey of elevation change, i.e. the amount of sediment they're collecting and the effective storage. And you can see in the bottom graph, which is the period 1, there's a little tiny bit of net erosion of about a cubic metre, just as they settle in. But in the wet period, they're collecting a lot of sediment, and there's net deposition. So their effectiveness is changing all the time, the amount of storage. So there's lots of variation in this, and we've also looked at other types of structures in this recently published paper here. What we need is good catchment scale examples. We do have them in Scotland. I'll not say too much here because I know Chris has a poster. The Edelston catchment, where there are many measures and it's monitored catchment. So that will help us with our knowledge database. And also the Interreg Building with Nature project helps us to learn from European partners about their approaches and their ways of delivery. So my final point, communication, delivery and funding. Well, firstly, communication. Well, farming and land use varies from place to place, so do the views and measures. And as I've just highlighted here, in sort of intense agriculture and extreme events, you'll get these sorts of flow pathways. But the last thing we should do is shout at farmers and tell them what to do. I can say this because my parents are hill farmers, and I know they don't like being shouted at. It's the wrong way forward. We can learn a lot from farmers about and landowners and foresters about the processes. They know a lot about the landscape. I also think we need to be careful about who to blame during floods. And I don't think blaming Monbiot, blaming the farmers, the Cumbrian farmers for the flooding there was the right way forward. Probably should be blaming Mother Nature itself. And again, Monbiot with the science as well. We have lots of good science, but we need to be communicating this effectively to the right people in the right way. So I think this sort of statement about the blame game and the communication of evidence, we need to do carefully. Work such as the Tweed Forum about communicating through catchment models, I think is great, and just getting this two-way conversation going or multi-way conversation going between partners. One way we've done this with a tool I developed with partnership with Newcastle University when I was down there, is the farm tool, and basically it's a matrix that tries to communicate the risk of runoff into those two categories I talked about in my earlier slides, the soil infiltration and tillage regime and flow connectivity as the two factors that control flooding in a field. You could say soil is a factor here, but we do it on a field-by-field basis to keep it more simplistic for the communication. And here's how it plots. So your risk would be quite high if your soil's in poor condition and highly connected to the ditches. And the top one shows if you have good soil structure, and wetlands disconnecting flow, then you're in the lower risk. But I certainly know we like to say that if you're down at this far bottom end, you're probably not farming. And this is the issue that I'll now move on to, is about what do we want from our landscapes? We still need to make food in them. And how do we ensure measures stay in for the long term? This is one of the first sites myself and Paul Quinn at Newcastle University started work with on this farm. And again, slides from linking to earlier slides, field runoff, what can we do? Corner of field pond, collecting a lot of fine sediment. So we built this. This was an experiment. There's no flood risk. It was just trying to learn about the performance of these features. And it's working nicely through time. 2009, the project ended, and the land manager was just left to take it on board to his needs. And it was removed. Now, the reason why I highlight this is soil buns can be removed, woodlands can be removed, embankments can be put back in. So therefore, you need to make sure that after the project's finished, there is new funding for maintenance and management, and partnerships are there to advise people when things go wrong. So we need to always make sure we're in this for the long run. And catchment partnerships are key to that. So I think we need to think beyond political cycles and be aspirational. I say that generational cycles, we don't know what's going to be happening politically in the next 10 years. So this is a challenge, really, but this is where we need to be going. And we should be thinking about flood risk solely. And I agree with David. We should be looking about, the full integrated catchment approach, looking at the multiple benefits and asking questions about what do we want from our catchment, learning from exercises such as the land use strategy pilot. And the statement at the bottom really also strikes home about in the Lake District, the National Trust trying to do good work for natural flood management there, but they get criticised for buying land and planting trees there because people want to see the landscape as Wordsworth did. So do we now expect our landscapes to be bare? That's what we've grown up with. What do we view from our landscapes? This is an interesting one and debates we need to have. So final thoughts, take a catchment-based approach. It's all looking at the sources themselves, the fields, the forest, down to the pathways, the rivers, and not forgetting this is not trying to take away from traditional defences, it's the full suite. The approaches may have varying impacts in space and time, as I've just demonstrated, but just going to Hayley's point about climate change, well, climate change carries a lot of uncertainty, but we know it's pointing us in the direction of change. Well, natural flood management is probably in a similar way. It has a lot of uncertainty at the catchment scale, but generally the uncertainty bounds are pointing us in the direction of it's doing good. And therefore, that's why we need to really ensure, we take this catchment-based approach. Just basically, even if we sold it on the multiple benefits alone, what the ecosystem services can provide. So I like to see it as a climate change resilience measure, maybe, climate proofing, even if it did add a centimetre or two, maybe off a flood peak. But, this is why we need to work more and gather this evidence. And delivery, catchment partnerships are key, but it must include the landowners, they're valuable, and the communities themselves. And I'm quite inspired to see communities themselves taking natural flood management forward and understanding what its limitations are and what it can do. And I'm quite inspired to see communities such as Stonehaven and recently at the Sniffer Conference, the Falkland Flood Group as well, doing natural flood management themselves. But we just need to ensure that we get good, the evidence as it comes along to them directly to help with the planning and long-term maintenance of these. I'd like to thank my co-authors and a few acknowledgements there, and I'll stop and take any questions.
Thank you, Mark. Yes, we've now got about 10 minutes for questions. And again, there are people with microphones, so if you can put your hand up if you've got a question.
Thanks to both the speakers, some very interesting talks. It's Tom Ball from University of Winchester, actually, not Dundee, has a programme, used to be at Dundee. A cross-cutting theme for both talks, so I think I can address it to both speakers, is the importance of something being empty. I think that came out from both the water, the B word I'll use, water butts I think is fair enough, but if they're empty. But I think it also came into Mark's talk, quite interesting there, with the Tarn feature and the other features that you pointed out from your previous work. Now, I suppose the question is there a trade-off between, particularly from the natural flood management perspective, Mark, the multiple benefits aspect of this and the engineering hydrology aspects? Because it strikes me that where we have the importance, as you've pointed out, of the feature draining out between events, so making sure that it is empty and doing its work, but also an empty feature not having those kind of wetland multiple benefits, the sort of things that the catchment stakeholders might buy into more. And I'm just interested in, I think from Irva's perspective, also David's view on this, whether there is a need to sort of find a happy medium here. And I think your double-ended arrow there at the end of your talk, Mark, summarised that well, of whether we have a kind of engineering versus natural trade-off and where we need to kind of fit in our hydrological work within that continuum.
Yes, very good point. In the Belford project, we tried to create a sole feature that delivered as many multiple benefits as possible to please all the stakeholders. It's very difficult. It's a very good point, because of course, I'm interested from a flood perspective, and like David, an empty feature is a good feature for flooding because it has further attenuation. But an empty feature for an ecological perspective is not very good. So like a wetland needs a wet area. So I like to look at this more as a treatment train, whereby you build a measure that's got capacity to, say, a wetland which has some water storage, And you could do that in very close proximity. In the way the buffer tech project I showed you is just a treatment chain in a very compact space, but you could actually make it on a larger scale if you wish. But yeah, I think we do. You need to have connection of measures and trade-offs.
I suppose being an engineer, I'm going to approach this from the engineering hydrology point of view. So, and I just think back to a scheme I've been working over the last few weeks, talking to the team about being clear about what the catchment faces at the moment. What are the flows that are generated from the catchment at the moment? And then looking at where do we need to be? How much do we need to reduce those peak flows to get to an acceptable level of performance? And from a very simple attenuation point of view, how much storage do we now have to incorporate in this catchment in order to achieve that? So having got that figure, we've then got over here, we've got the toolbox. So we can now start selecting things from the toolbox, and each of those can do different things and be appropriate in some areas and not appropriate in other areas. But if we can't, with the range of measures we're pulling out of the toolbox, generate that amount of storage volume, we're not going to deliver the amount of attenuation which we need. And I'm very excited about all the multiple things we can do with these measures, as I've mentioned in the presentation, and I think was nicely demonstrated in the last presentations. But what I don't want to do, what would be a tragedy, I think, here, is misleading people about what can be achieved with these different measures, simply because we just don't get some of the basic numbers right.
Yeah, just adding onto that one, I would say, although we talk about multiple benefits, you don't have to try and achieve all the benefits from one measure. So you can have a range of measures to achieve a range of benefits. But also, some of the examples that David was giving about storage areas in an urban context where you're quite happy that they're dry most of the time, and that's a kind of recreational space, and then it's then used for storage in a flood event. So it's thinking about the range of different measures you can use and the purpose you want them to fulfill. Right. Any other questions? Lady at the back then.
Hi, my name is Emer Owens from EnviroCentre. David, you directly referenced some difficulties in sort of municipal planning policies and approaches, and certainly your slide showed a huge difference across countries of how open they were to innovation on flood resilience. And I'm sure, Mark, that you've come across similar. In your opinion, whose responsibility is it to start lobbying a changing approach to innovative engineering and innovative techniques for flood resilience? Say is it the likes of professional engineers, hydrologists, statutory bodies, or even, due to your involvement with ICE, professional bodies such as themselves? Because I think the industry is in danger of perhaps implementing what's allowable by policy rather than being innovative, and especially that's due to a client has only so much budget, so you go exactly as per what's policy, and they don't want to risk being innovative and going down the wrong path if it just gets rejected.
Well, we could have quite a lot of discussion around what fosters innovation and what are the barriers, but we won't do that. Let me just say a couple of things. A little while ago, I did a study of international best practice in this area on behalf of Ofwat, which is the water company regulator in England. And they wanted to learn more about this exact point that you're making. Who's responsible? Does the organisational structure make a difference to what fosters the delivery of some of these more innovative methods? And what I found to that question, the answer to that question was no. You listed a whole range of different potentially responsible bodies there, and said, who should lead on this, and which one of these should, and I would say, yeah, all of them potentially. But what actually is most important is having a local champion. It's somebody from one of those organisations who has the vision to do something differently. So that's the first thing. The second thing, of course, that needs to happen then is that person has to be properly supported. But I think one of the dangers we have is when we come up with a new way of doing something, we all sit down and we put all our energy into working out all the different things that are going to get in the way of that working, why it won't work. And that's the main reason, in my view, why things don't happen. If we put that energy into answering the question, what would it take to make this work? So, if you've got a champion in place and they've come up with an idea which they're passionate about, what you focus on working on is, what would it take now to make this work? And you work slowly with all the different parties, and sometimes it does take time. But I would really encourage those of you who have a mind to go down some of these new pathways to do exactly that, because you will get there in the end. It is difficult and it's hard work, and sometimes it's difficult to see change, because change is difficult to see on a day-to-day basis. But at the end, you'll turn around and you'll look back over that period of time and you'll think, wow, we really did it.
Yeah, very good point. And just to follow up on that, I fully agree with that. And it's not really a linear scale in terms of time needed. We found in Belford, actually, the natural flood management scheme there, it was the first feature that took so long, because you had to get everyone together, understand everyone's needs, what you need to do, this aspect, that aspect. And even the farmer just shown, listen to an example, his opinion. But when everyone sees it working correctly, and you get that little bit of evidence, then you start to rocket off and deliver a lot more things. But it's usually at the beginning that's the slow bit. Generally, it can change case by case.
Okay, I think we've probably got time for one more question, if there's one. Ooh. Well, okay, I've got one final question for you, Mark, then, is what do you think we need to do next in Scotland in relation to taking forward implementation of natural flood management?
I think there's a few things, but the key one is two aspects. First one would be integration, and try to work closely with our partners in, say, diffuse pollution. As I've just highlighted, there's a lot of measures there, diffuse pollution measures, which have a natural flood management benefit, and they could be optimised to have flood storage. I think that's a key aspect. Secondly, I would probably say is there's lots of good legislation there, there's lots of good top-down tools, but we just need to encourage the bottom-up way of thinking as well. These community groups give the support there, give the knowledge. But I think we're in a good position sort of from a policy top-down level. It's sort of, we have lots of natural flood management plans being developed by the local authorities at the moment, but how do we implement them? How do we convince the landowners or have that dialogue? So I think it's getting that next step correct. So we've got the sort of plans and the knowledge. It's now how do we implement it?
And it's the same in the urban context. It's exactly the same.
Right, okay, thank you. So I'll be handing over now to Professor Roger Crofts to chair the next session. But before I do, could you just thank the speakers, please?
I thought there was a mad rush for the door then, but don't take it personally. The next three speakers, I'm Roger Crofts, Chair of the Royal Scottish Geographical Society. We published our magazine, The Geographer, and an issue on flooding in autumn 2014. If you haven't seen it, go on our website. And I think we are going to try and persuade all the speakers to submit their papers and publish them in the Scottish Geographical Journal, because it's ideal. I'm biased, of course, but geography is the bit that connects all the pieces, and therefore is the subject of our time. Anyway, that's the end of the slogan. We're now moving on to dealing with the impacts of flooding. And we've got three speakers, and I'm delighted to welcome first Michael Cranston, who is an honorary research fellow at Dundee University and has recently set up the Scottish office of RAB Consulting. 10 years of flood warning developments in Scotland. What opportunities remain? Over to you.
Thank you very much, Roger. Okay, good afternoon, everybody. Thank you, Alan, and the committee for the wonderful opportunity to speak and present, and great to see so many colleagues that I've worked with over the many 10 years and beyond. What I'd like to cover today is in 4 parts. I actually want to step back to before the Act, which has been referred to several times today, and the Flooding and Flood Risk Management Inquiry, which, show of hands, who gave evidence in that inquiry 10 years ago? There should be more than one. Come on. 2. There should be more than that. I know a few people. When I've read it in the last few weeks, there's a few familiar names there. So I want to touch back to the inquiry, because noting Alan's driver for today is looking to where the challenges are, where the future opportunities are. We had similar questions back in 2007 and 8. So actually, what have we achieved in the intervening 10 years? What's changed? Have we improved flood warning? Then I want to touch upon a research project I'm involved with at the University of Dundee on assessing the effectiveness of Scotland's public flood warning service, which is, thanks to SEPA, it's very close to concluding. They gave us permission to present some of the findings today, which is excellent. And then just 2 slides at the end on what I consider, and shared these views with a few people that I've got respect for, in terms of future opportunities in flood warning. I'm going to start with my acknowledgements. I'd like to thank David, Pascal, Cordelia and Louise from SEPA for comments on an earlier draft of this, which meant I had to get the slides done 2 weeks ago, which was great. And then colleagues at Dundee University, Alice, give me a wave, thank you, who's our research assistant on this project. Any awkward questions, Alice, be lined up for them. Andrew, Alistair and Alan, who's on the project team as well. And then just 2 references at the end, Crew, who's funded this research work, and something right at the end, we've got an incubator grant funding from Checker, which I'm going to refer to as well, and the future challenges. Okay, flooding and flood risk management inquiry, which started about 10 years ago, reported in 2008. There's a lot of talk this morning about flood-rich periods. This inquiry clearly was formed on the back of a flood-rich period. I've got a few interesting floods, starting in with Strathclyde 1994. There's been a few images of that today, and Glasgow 2002. Elgin 97 and 2002. Hoyk in 2005, which I'll refer to, and Stirling in 2005 and 6. So really on the back of some significant flood events, and you can see 2 images there. Now this drove obviously a lot of thinking around how we can improve flood risk management in Scotland, which ultimately led to a more sustainable approach through the Flood Risk Management Scotland Act, which you've heard about. So what I want to do is reflect on the flood warning aspects of that inquiry, look back at some of the recommendations that were made, and reflect on what they achieved and how far we've come in the years since. So, see some quotes there from the inquiry. The key for flood warning was around the continual development of the warning service, and in addition suggesting greater emphasis on effective warnings, and I'll talk about that in detail. And there's an interesting quote from ACPOS, the Chief Police Officers of Scotland. They were involved, and I was talking to Richard Brown earlier, in terms of their role in flood warning from the 80s and 90s, where they had a role in the cascade systems in many catchments. And they said public expectations around flood warning systems can never fully be met. So obviously that is a big challenge, and they were speaking from experience. So I'll go through that in terms of have these challenges been met through the flood warning service over the years. One of the first recommendations was around giving SEPA the ability to disseminate flood warnings to end users. At the time, warning dissemination systems were sporadic. There were different arrangements in different locations. Some local authorities had taken on the responsibility, like Scottish Borders Council. The police were making noises to move away from cascade arrangements because of the introduction of the floodline call centre, which came into operation in 2001. So on the back of funding from the Scottish Government, SEPA introduced an active dissemination system of flood alerts and warnings, which after 3 years of development went live in March 2011. A large programme to develop a multimedia system to disseminate warnings to anybody who wanted to register, free service. And that service has grown significantly over the years. There's now 26,000 customers, the last I heard anyway. It's probably gone up since, given that it is growing on a regular basis. So that's been a big change, and I'll reflect on the public research that we've done around the effectiveness of this public service. Another recommendation was around upgrading flood warning systems and expanding to uncovered areas. The development of flood warning, as likes of Richard and Nigel would know because they've been involved in it, was largely on the back of major flood events in local areas, the Tay scheme, the Highland scheme. These were developed by local need. There was never a really national approach to this. So starting with the new schemes in the southwest, the Clyde, Kelvin and Irvine, and the new schemes in the northeast of Scotland in 2010, SEPA published the flood warning strategy in 2012, and it was the first opportunity to really take a prioritised approach and a national approach to the development of flood warning. That's a picture of the floodline customers and registrations as of 2012. And one of the aims was to obviously increase the coverage and look to, as Mark mentioned earlier about potentially vulnerable areas, to aim to achieve flood warning to 65% of these areas by 2016. Now this coverage is obviously expanding further. There's plans to launch the Cree, Loch Lomond and Garnock schemes imminently, and then SEPA recently published the new framework for flood warning as well, which looks to the next 4 years of further expansion. One of the biggest challenges around flood warning, as anybody's been involved in this area, and it still remains one of the biggest challenges, is surface water alerting. One of the recommendations in 2008 was around filling the void that exists with regard to pluvial warnings. Now, back in 2013, we had funding through CREW to get the lead scientists together through CEH with the grid-to-grid capabilities and the Met Office through their high-resolution precipitation models to look at how, in terms of the science, we could develop a forecasting capability to underpin surface water alerting. Now, the driver was for Glasgow, given the Commonwealth Games in 2014. You've seen images of Glasgow in the big 2002 surface water event. And the idea was, could we develop a system to give the responders, emergency planners during that event and the games organisers a heads up 24 hours in advance of potential for flooding? Because if you've got any games activities going through potentially flooded areas, clearly that will be an issue for them. Out of the science came a pilot of a surface water alerting capability. If you want to read the full report, it's on the crew.act.uk website. And it was a real novel approach combining ensemble rainfall forecasts to the grid-to-grid model, looking at surface water runoff, and then linking to an impact library of impacts, people and property, transport, railways, roads, as you've seen earlier about the road pictures in terms of flooding in 2002. So it's quite a novel approach, and it was the first UK operational surface water flood risk forecast. I mean, the capabilities, as Nick alluded to, has developed further since. But it did really answer the question of filling that void that was posed back in 2008. One of the other recommendations is around collaboration between the Met services and the hydrological services, providing effective warnings for all types of flooding. So building on what I've said around the surface water capabilities, back in 2011, the Scottish Flood Forecasting Centre service was established. Issuing the flood guidance statement, that went live in 2011. How many people, again, hands up, sorry, activity afternoon, who receives the flood guidance statement? What would we do without it now, if you think about it? It's incredible, the step change in what that's delivered in the early heads up. And I encourage you, if you've not seen it, go and see the poster paper by SEPA in terms of the early warnings and the communication, the build up to Storm Frank, in terms of having that 5-day forecasting capability. It's a real step change. In terms of underpinning that, the science capabilities about linking high resolution weather models. Haley mentioned the UKV model, also MOGREPS, which is now coupled with countrywide flood forecasting capabilities using grid-to-grid. And that's an example of Storm Bertha, where you can see output from grid-to-grid, linked to forecasts at a gauging station, and then that's the area of concern map that was produced on the back of that. Coastal warning systems is obviously a key gap back in 2007 and 8. There was only the Firth of Clyde flood warning and forecasting capabilities in operation. And the recommendations clearly followed the fatalities that we had, unfortunately, with the West Nile storm in 2005, which then led to the introduction of the Storm Tide Forecasting Service. Now, since then, There's been a lot more focused attention on developing forecasting capabilities, particularly around wave forecasting and wave overtopping. Mark mentioned it earlier in terms of the gap there. It started in 2002 with the Firth of Forth scheme, which introduced wave forecasting and overtopping for the first time. Clearly a big issue for us. These capabilities have now been introduced in a number of locations and will continue to do so. So just to conclude, I'm going to finish on this slide, which I've used quite a bit before, and I mentioned 2005. You probably all remember the build-up to the 2014 weather bomb. This was put across the media quite a lot. There's probably a lot of fatigue about the messaging going out about the weather bomb, but actually, were we better prepared about it? Science capabilities led to early forecasting of that, and that's the flood guidance statement for that event. And if you compare it to the tragic fatalities from 2005, what impacts did we experience in 2014? There was power loss. We can live with that. I think we were all better prepared. I think the messages led to a response which mitigated flooding, which I think is a good thing in terms of the capabilities that have changed. Okay, so 2015-16, the storms. That was clearly a big challenge to everybody in terms of the response. Those providing the flood warning service, it was a big test of the systems that had been introduced, a big test of the people behind the systems and the messaging. And following this, SEPA through Crew commissioned a study to look at how effective were the warnings that we provided. A couple of interesting stats, or one interesting stat, 300,000 messages went out during those months through the Public Flood Warning Service. So how effective was that in generating a response? What actions were taken on the ground? Who responded to them? Were the messages timely? Were they acted upon? These are all of the questions that we've been asking over the last few months through this research project. Our approach was to develop a web-based questionnaire which went out to all the floodline customers that we had emails for, which wasn't all of them unfortunately, but it was about 19,000 customers. We had a very good response. 1,300, over 1,300 responded and have provided some excellent feedback, comments. The survey was designed for the first time to really test where the customer was, the location, the risk, the type of warning that they received, previous experience of flooding, different demographics, just to really test how different customer groups are using the service. And we've also carried out a number of workshops which have been fascinating, just to explore some of these, some of the feedback that we've had in a bit more detail with customer groups. This is a picture from Nethy Bridge back in January. And it was a fascinating evening in Aviemore, actually. I'll mention this one. There's a chap that came along, really interesting chap. You know, unfortunately, he's been flooded many times in Aviemore. I think it's the first property flood. He's been there 40 years. And he said, don't need SEPA to tell me when it's going to flood. I know when it's going to flood. And the guy came out with a notepad of all the records that I've got from his back garden to his house of every event that's occurred there. I mean, that's fantastic knowledge and should be captured. And hopefully we will capture it during the event. So really interesting comments we've had back during the process, which has been wonderful. We've taken the responses and obviously split them into different categories. We've geocoded them to make sure we know where the customer is, so we can then do further analysis on the type of warning they get, where they are, the risk. You can see here some of the statistics in terms of from the different message types, so alert, warning, or both alerts and warning customers. The percentage of those who've received messages in the past, which is a high number, and then the percentage of those who've previously been flooded, so we can understand experience and how that affects your response. And that's just a map of the distribution of, it's not a clear map, but gives you an idea of those who've responded to the survey. What we've also done as well is to try and categorise the warnings, and this is going into a little bit of detail, but we're keen to understand, does response to warnings, is it influenced by the frequency of warnings? So how many warnings do you get? Does that affect how you respond to it? And then the potential impact. So a simple plot here, if I'm a landowner, I've got livestock, which the warnings probably go out more frequently than other warnings. Do I respond differently to say I'm a property owner on the slit rig in Hoyk, which only goes out very rarely, but when it does go out, it's quite a high impact. And you can see the 9 categories you've got here. Apologies if it's not very clear, but these are categories in terms of the frequency, so low, medium, high, and then the impacts, low, medium, high again. Quite pleasing to see we've had a very good spread, and it matches the SEPA customers quite well. So the lighter blue is the percentage of SEPA customers per category, and then the purple and the red are the survey responses that we've had. So we've got a good spread across the different customer types. So how satisfied are floodline customers? Just a couple of interesting pieces coming out here. Like I said at the start of the talk, we haven't finished the project yet. We're due to finish in the next couple of weeks, so these are really headlines coming off the analysis that we've done. So of those who responded, a high proportion are satisfied, 66% overall satisfaction. Interesting there that satisfaction does not depend on previous experience of flooding. There's no significance between the two. And then satisfaction is slightly higher with those who receive both types of messages, so both alerts and warnings, rather than purely just the alert or the warning message. So, simple comment. We've had lots of comments, which are great to capture and feedback. Keep them coming. Much appreciated. When I mentioned we've split the different types of flood warning areas into 9 different customer groups, or flood warning classification, this is an interesting plot that we discovered a couple of weeks ago. And you can see on the left of the graph, blue is customers who are highly satisfied, and red is those who are more neutral or unsatisfied with the service. So on the right are the ones, the warning areas that have been issued a high number of times. You're probably looking at, I think how we've classified this, greater than 8 times or 9 times. So those who get messages on a regular basis tend to be highly satisfied with the service. But actually, if you look to the right, the lower frequency, there's more of a less satisfaction with the overall service. And that was an interesting one for us when we saw that. Thank you. What about locally specific information? Through the workshops, people do get the principle of a stage flood warning service, so messages going out when it's possible, likely, significant. A couple of interesting ones here. 57% of those who receive only the regional alert messages believe it's a service for locally specific warnings. So these are messages going out for whole regional areas, when actually they think that service should be about locally specific warnings. So they're not really understanding that element of the service, unfortunately. And then 74% of these alert-only customers who said the messages were too frequent also said that the impacts were not as bad as conveyed. So there's an element there of potentially with the alert component, crying wolf, too frequent, not being locally specific to the individuals. What actions do people take? I'll go back to the cars shortly, but 71% who said they had property level protection measures deployed them when they received flood warnings. 62% of landowners who said they had livestock moved the livestock. So there's a big response in terms of the warnings going out and leading to actions. 42% of all responders said they removed vehicles on the receipt of a warning. There was an interesting anecdote from the emergency planner from Scottish Borders Council. 2005, when Hoyk was flooded, there's a picture of the high street with cars being washed down the high street. And he said on the back of Storm Desmond, they happened to notice that not one single car was flooded in Hoyk. I think that's an interesting one in terms of the early preparation and planning that led up to that event. So some early conclusions. Customers of the Floodline Public Flood Warning Service are largely content. Least content, the least content customers are those who do not receive regular messages and are less likely to be engaged with the overall service because they're not really hearing about it. Flood warnings do lead to actions to mitigate flooding, as I included in the last slide. However, the regional flood alerts are probably less likely to lead to actions, given the lack of locally specific information, but also typically misunderstood about the role of the flood alerts. And for those who are well engaged, through the workshop, there's clearly an appetite for further access to river level information, even flood forecasting information. The amount of people that use the river level sites that SEPA have, the chap in Aviemore, okay, he doesn't receive the flood warnings, but he does go to the river level site. That's quite key. There's a high level of use of that. But there is an appetite for further information. We did present a couple of messages from a duty officer in Dingwall, which referenced forecasts. And the group said, well, that'd be wonderful if we could receive that. So there's an interest there for further information and to help them respond. So last 2 slides. Got time for this? Thank you, Roger. What opportunities remain for flood warning? I structured this around 2, one around science and one around communication of warnings. The science, and I go back to the inquiry again. And where's Jim? Thank you, Jim. Jim will know about this because he probably has to handle the Scottish Parliament inquiries about having high-resolution radar for the whole of the country. How many times has that question come up? Half a dozen, yeah. Now, SEPA, Met Office and NCAS are involved in a trial of an X-band radar up in the Moray coastline. Lovely piece of kit, and that's an example of the output there. But actually, is it about, which wouldn't be feasible in terms of cost benefit in terms of covering the whole of Scotland in C-band radars, is it more about using the information that we've got in providing better precipitation estimates? And there's a couple of initiatives underway at the moment about merging radar and rain gauges. So using SEPA network of rain gauges to then improve the radar coverage where there may be issues with overshooting of the rainfall, etc., and areas like the Moray coastline, which is quite poor for radar coverage. But also improve radar orographic scheme as well. I'm pleased to see Marjorie in the audience. She did a bit of work in the 80s, early 90s, particularly around this. And it's fair to say that I don't think we've really got there in terms of the orographic scheme yet. So I know there's a piece of work underway to look at that scheme again. In terms of modelling, looking back to what was achieved through the Glasgow surface water pilot, can we start looking at similar uses of the MOGREPS UK model, high resolution ensemble model, to then better predict, particularly for flash flooding and flashy catchments like Comrie, Stonehaven. This is a plot on the left here from CEH and also work from Clive Pearce at the Met Office. The blue, this is from the flood in 2002. The blue is the hydrograph, the observed hydrograph for the Erne, or the Ruckle water, sorry. The red was the forecast that we had at the time. Now the green was a pilot of using actually steps, high-resolution ensemble predictions into the grid-to-grid model. And you can see here the green plot suggests that this higher resolution model gives us a better chance of predicting these type of events on a short-term forecasting basis. Then around flood warnings, learning from, thank you Roger, learning from the surface water trial, what we're doing with a small piece of work with Checker, we're looking at how we can communicate surface water alerting when there's so much uncertainty. When there's so much uncertainty, how could you encourage somebody to take action in terms of moving cars or installing property level protection? And what we're looking at here is just to test a few different methods, building on the risk matrix that are now commonly used with the Flood Guidance Statement and the National Severe Weather Warning Service, but actually stripping it out and saying, well, okay, what's the risk to people, property, transport, in the same way that we did that with the Commonwealth Games trial, but actually can you do it to make it more focused on different impacts and different receptors? So there's an initial workshop planned in April, and we hope to come back with some early findings from that to think about whether there are new ways of communicating risk. Okay, I think that's it. Thank you very much for your time.
Thank you very much indeed. Those of us that live in flood risk areas ought to be really reassured by this amazing attention to detail, but also listening to what us, the customers, want to get from these flood warning systems.
Yeah.
We now move to that really important question of flooding insurance. And it's a delight to welcome Edmund Penning-Rousell, who's been working on this, I think, for many decades, should we say.
Still haven't solved the problem, Roger.
Well, how do you solve the problem of the insurance industry? But I'm sure you're going to tell us something about that, what its limitations are, and the importance that it has to all of us. Edmund, over to you.
Thank you very much, Roger. It's a pleasure to be here at the RSE to talk about flood insurance in this really useful and exciting meeting. So I'm going to talk about the nature of flood insurance and when it's not viable, how we in the UK stand up to those criteria of viability in an international context. I'm going to talk about the situation in Scotland and analyse who gains and who loses. I'll touch on the situation, the new Flood Re proposal, which went live in spring 2016, and draw some conclusions. Now, one of the problems with insurance generally is that there are certain conditions that have to be met to make sure it's viable and for the companies to remain solvent. It must be possible to estimate the likelihood of loss. If you can't estimate the likely loss, you can't run an insurance portfolio. Losses from individual properties should be independent and random, and no single event should affect a large proportion of the properties insured. In addition, the occurrence of a loss should be fortuitous, not capable of being predicted specifically. You shouldn't be able to predict specifically if there's going to be an event tomorrow or the day after. Otherwise, people will only insure for tomorrow, not on a continuing basis. And, of course, the size of the premium should be acceptable to the insured, otherwise they weren't paid. And that's from Nigel Arnell's paper, which you can read. The problem with flood insurance is that it fails the second criterion. That is to say, you do get very large flood events where all properties which are insured in that event claim simultaneously. And when you get that situation, the company involved can become insolvent. And that's not really what you want to have happen. So we have a problem here, ab initio, with flood insurance. And, as I say, it fails for big events. And the major events can destabilise the insurance arrangements by making the companies insolvent. So we have to be careful. And you do get big events. Here's Desmond. You do get events that affect thousands and thousands of properties, as we have in Scotland and as we have had in England, particularly in 2007. And in the USA, they've had major flood events which have crippled the National Flood Insurance Program. This graph shows the debt of that program to the US Treasury, from which it has to borrow funds to pay for compensation claims. And it's now standing in excess of $30 billion US. So organizations like this can become unviable. So we have to watch out. Secondly, how do we stand in an international context? And we've done some research on the robustness of insurance regimes worldwide. And what we looked at is 32 insurance regimes evaluated for their robustness, that is to say their solvency, their technical solvency to climate change, looking across the world. And it's amazing what variety there is across the world. So, for example, in France, you have a system whereby flood insurance is compulsory because it's added on to your compulsory fire insurance, a very simple, mandatory arrangement, 100% penetration rates, as we call it. In other countries like Italy, you have less than 5% penetration rates because it's offered as an option onto other disaster insurance arrangements, and the option is not taken up by people who don't think they're at risk. And therefore, disasters, as it says here, are often covered by emergency taxes, which is really the last resort of a scoundrel in this particular area. In UK, we have about 95% penetration. If you know about your flood insurance, you'll know that it's bundled in with other insurance for your property, like fire, theft, subsidence, burglary, all those other perils that you might face. And you cannot separate out the flood insurance component of your insurance policy. That's a good thing in some respects, but of course a bad thing in other respects if you don't have a flood risk to insure against. What are our conclusions? Our conclusion is that the solvency of insurance arrangements in the UK are particularly strong. We have a very, very powerful, very strong insurance industry. Changing risk may threaten solvency if increasing risk, as we've heard today, is not recognised and adjusted for. But the best, robust insurance policies are those which are based on some sort of market system whereby premiums can adjust to the kind of risk changes that we might face in the future. You may not like to have your insurance covered by a market private system, but it's actually robust in technical terms and hinders the process, reduces the process whereby insolvency might grow. And you can read that paper if you wish. Now, what about the situation in Scotland? I've been involved in a Joseph Rowntree Foundation sponsored project to look at flood risk across the country, building on the climate change risk assessment done last year. And here we have a map of the number of people exposed to frequent flooding up and down the country. And it's adjusted so we only concentrate on the areas which are particularly flood vulnerable, the particularly vulnerable communities in terms of their socioeconomic characteristics. And there's your map of the number of people that are affected. In terms of annual average damage, a long-term average there of these communities, we see that Scotland has its particular problems in the central belt, where there is flood damage occurring and has the future of continuing that damage in future floods. So that's more or less in balance with the number of people exposed. But what we also did is we looked at what we call the pain element of this, which is relating the damage you might incur in future floods to your economic circumstances at a household level, mitigated by the amount of insurance you might have taken out. So if you've got low damage and you've got insurance, your pain threshold is low. If you've got lots of potential damage and you're economically rather deprived and you have no insurance, the pain value is high. So what we see here is that Scotland has a particular problem which is not matched elsewhere, of a high pain threshold, a high pain level in terms of its susceptibility to damage which cannot be recouped by insurance cover. Now, that is added to by the fact that our analysis shows that the annual average potential damage per individual, taking individuals from these different census districts, is actually higher in Scotland than the other three countries. So the potential for damage is higher in Scotland, and I'm afraid your insurance penetration levels are lower. Now, here is a diagram which shows the insurance penetration levels, the amount of insurance taken out by the population as a whole in the rest of the UK and Scotland. And these levels of no insurance at all of those particular households, no insurance. It's 21%, 21.8% in the rest of the UK, but it's more in Scotland. You have less insurance in Scotland proportionally than you have in the rest of the UK. That's unsatisfactory. Why is that the case? It's partly because you have very high levels, as we do in the rest of the UK, of the lack of structural insurance for the property, the building of the property, whereas the contents insurance is broadly balanced. That's partly because the contents are covered by an insurance policy taken out by the householder, whereas the structure is a policy which can have to be taken out by the landlord or local authority. The situation doesn't get any better when you look at income deciles. So the poorest 10% by income decile are on the left-hand side, the richest on the right-hand side. And what we see then is that somewhere around 50, 54, 55% of people in the poorest 10% decile do not have any insurance at all. They are susceptible to the kind of damage that we see in poor communities from floods in the past and will see in the future. If you look across the different types of tenure, the situation gets worse again. So here we have the tenure of the property the one circled here as housing associations. We're also looking at private tenants. We're looking at locally authority property as well. The numbers are relatively small, but the total sample, this is from the ONS Living Costs and Food Survey, is high at over 5,000. And what we see is that all tenanted accommodation has far lowest amount of insurance when compared with the owner-occupiers. And in every case, it's worse in Scotland than it is in the rest of the UK. Now, there's no real difference between the tenure breakdown in Scotland, between that and the rest of the UK. There is more private rented accommodation in the rest of the UK than in Scotland. So that's a good thing in some respects, because we know that the private rented accommodation people don't generally insure. But the situation in Scotland, again with your private rented sector, is not very good, really. This particular statistic, Scotland has the highest amount of tenants in conflict with their landlords for poor quality housing. A quarter of renters in Scotland say they have a slum landlord. Not only do they have poor housing, they're also relatively uninsured against flooding and other perils. So, just a reminder here, the tenure breakdown has a huge effect on flood insurance propensity. That's not because Scotland is less affluent than the rest of the UK. Figure here from Earnings in Scotland survey show actually that the annual full-time pay in 2015 was very slightly higher in Scotland than the rest of the UK, for which you deserve my congratulations. But when it comes to tenure and the affluence of the tenants, then you see that the poorest 10% tend to live in housing association and private rented accommodation, whereas the richest 10%, as you might expect, are owner-occupied. And that's a factor causing the level of underinsurance. The central belt of Scotland, where I showed you those maps previously of economic pain or annual average damage, actually, as you know, is one of the more affluent parts of Scotland. So it's not just affluence or poverty that's causing underinsurance. It must be something else. You probably know better than I do. Another worrying trend is that the private rented and the rented sector generally is increasing over time. And as we know from other reports, the amount of owner occupation is falling slowly. So this problem is probably growing in that those poor people in private rented accommodation are likely not to be insured properly against flooding. And the same is true about the rest of the UK. The private rented sector is increasing quite rapidly when you look at it in historical terms. So coming back to this rather dismal diagram, a fifth to a quarter of our population is inadequately insured against flooding and will suffer accordingly. And those are the people who are unlikely to have the savings. They're unlikely to have the resources which will help them recover from the flood that damages their property when it comes. Another reminder. So let me pass on to who gains and who loses, and this is not just about Scotland. If you look at the situation with regard to risk and insurance, you'll find that the variation in insurance premium is almost unrelated to risk. Two rather old PhD theses which I don't think have been confounded yet. Today, I think there's very little, if any, evidence that insurance premiums come down when there is investment in flood defences. Premiums don't come down, they stay the same. When SEPA or the Environment Agency invest heavily to reduce risk. So let's look at the logic of that. Individual flood victims who are insured do not gain financially from insurance when they're flooded. They should end up the same after the flood as they were before the flood financially, if they're insured. But if there is investment, number two, from the state or others in flood risk management, event losses should decline. That's what the investment's for. If there's no such decline, that investment will not have been worthwhile. If there is decline in flood losses as a result of investment, then insured claims should be fewer or lower or both. This should be reflected, therefore, in lower premiums to be paid by those whose flooding has been reduced. If there is no such change in premiums, then the insurance company will retain the full premium income, but have much lower costs. This should result in the insurance company making larger profits and giving larger dividends to their shareholders. So the logic of this, on this basis, all the SEPA and Environment Agency investment in flood risk management measures to reduce risk goes straight into the pockets of the insurance company shareholders because they don't reduce the premiums. Interesting, isn't it? Premiums are not particularly high. This is the average premium for a household policy in this country, coming down slightly, but it's still not an insignificant household expenditure. But we heard a little about Flood Re. Now, Flood Re is galloping to the rescue of people who are in high flood risk areas. It's an insurance arrangement for insurers. It's a reinsurance arrangement, which caps premiums at a certain level. But it's only available for those who insure, not available to those people who I've described as not insuring. What happens, and what will happen, what happens now, is that those premiums are set in future by your level of council tax bands. And the 5 bands here, with the A to H bands here. Flood Re charges the insurance these amounts, whatever the claims are that comes in. And that's a subsidy to those who would otherwise suffer by having large claims which cannot be met because their insurance policy doesn't cover them. A subsidy. But of course, the subsidy discourages self-help. You're not likely to do much to help yourself if you know that your flood claims are going to be heavily subsidised within the Flood Re arrangement, a major criticism of Flood Re. It also includes the very highest council tax bands in the country. So this particular estate in East Lothian, which I have a nice picture of here next to its river, the new owners of this bought it for £8 million in 2015, will be comfortable in the knowledge that their flood insurance will be subsidised by everybody else who pays the insurance premiums. A rather strange situation, you might think. But Flood Re has a finite life of 25 years, and the first transition plan has been launched by Flood Re last year. And what they hope to have happen is outcome B. They hope to move towards a fully risk-reflective pricing arrangement for flood insurance, which will provide available and affordable flood insurance to high-risk households. The other outcomes, A, C, and D, are less satisfactory. But this means, as Flood Re passes out over 25 years, that the subsidy will decline quite markedly as we move towards flood-reflective insurance premiums. And people's insurance premiums will go up quite substantially. They will already be higher because they're now market council tax related, but they will go up in the future. But Flood Re hopes that that will not be the case by reducing flood damage costs. How will they reduce flood damage costs? Well, that's to be debated. But they want to maintain affordable flood insurance, and that depends on driving down the costs of providing it. You can do this by reducing the extent of risk, the cost of claims, and they say you can achieve it by greater competition in the marketplace. But how are we good at reducing risk? Well, in England, the Environment Agency's huge programme of 2.3 billion investment to 2021 will only reduce risk by 5%. It's hardly scratching the surface. I don't know what the situation is in Scotland. We could debate that.
5 minutes.
Okay. Climate change, possibly increasing by 20%. So we have to repair flood damage better. We have to dry out our properties better. We have to have less temporary accommodation and try and get our administration costs down. We've been studying at Middlesex University flood damage for nearly 40 years. This diagram here shows the change in real flood damage between 1977 and 2016. And what it shows is that real flood damage for the average residential property has gone up from something like £5,000 to £21,000 over that period. Why? Because your houses and my house is full of new things which are highly damage prone. I mean, we're not so full of them 40 years ago. Damage potential is increasing, not decreasing. So Flood Re is really up against it in this respect. There have been many changes in the methodology, but basically those figures are quite interesting and quite revealing. Why? Because our GDP has grown in that period by something like 1.98 times. We're 1.98 times richer than we were in 1977. And that's why our flood damage potential has gone up by something like 2 times. So how do we actually provide flood insurance which is affordable when flood damage potential is going up is a complete mystery to me. And also Flood Re has attracted serious doubts. This is from Daniel Johns from the Climate Change Committee. They're very cagey about data. They've only had 53,000 policies on their books after 6 months, whereas they set the target of some 350,000. If they don't meet that target, it means that Flood Re is well overblown, and we're going to be charged too much of it through the insurance subsidy. There is commitment to work together between Flood Re, but Daniel says there's no sign of it so far. They are accountable to Parliament, so maybe we'll know in the end, but we don't know yet. What about the future of flood insurance itself, to be completely left field? We're seeing huge improvements in data about flood risk, about the potential for harm. Perhaps this will lead to a move to unbundle a policy, so you can click to have flood insurance as well as your theft insurance and your fire insurance. Unbundling it would provide people with choices, and choices are what people need and want. Should we allow people to insure long-term rather than annually, so as to have a longer-term perspective over their cover that they receive? I wonder if we can have a situation where you insure just in winter. Why not? People are going to have choices. They demand choices. Insure in real time when floods are forecast. You could have a situation where that occurs. We're not stuck in the past, or we shouldn't be stuck in the past. So some conclusions. Flood insurance is really important to underpin all other aspects of flood risk management and can be resilient. Our insurance arrangements are resilient when tested internationally. But penetration is far too low for certain groups, especially in Scotland. The insurance industry in this respect is failing in its social duty. There are ways of providing low-cost insurance to low-income families. They're hardly being discussed, let alone implemented. Flood Re discourages self-help and perpetuates undesirable inequalities of assistance across community groups. I think the picture looks a bit grim today. The future looks no better. Thank you very much.
Are you all depressed now? But isn't there a real message that we have these pockets of long-time social deprivation in Scotland, and this is just another factor piled in those areas, despite hundreds and hundreds of millions of pounds of government money we've spent on it in the last 40 to 50 years. That's a really significant message, I think, from there. Final slot today. I'd like to welcome Johan Fazy from Dundee University. Johan heads the Centre for Environmental Change and Human Resilience, a really nice connection there. And he's going to tell us about that essential part of flooding community engagement. Johan, over to you.
Thank you. It's a real pleasure to be here. This is the last one. Hang in there. You're almost there. Okay. So just a quick set of acknowledgements. I'm going to be talking about a range of things, but there's a huge number of people who put a lot of effort into the kind of information that I'm talking about. And Esther, the first person, Esther Carmen, is actually in the audience here as well. So talk to Esther about some of the work we've been doing afterwards. So I'm going to talk about managing flood impacts community engagement. It's kind of the interesting question. This is the people side. We started to get into that already with the insurance. I'm going to talk more about that. I think people are fairly central to this whole problem. And actually, we haven't had a lot of talk about people so much in so far today. So I'm really going to talk about that. Now, community engagement, though, is a kind of slightly challenging kind of topic because it depends on engaging for what, with who, and all those kind of things. So I'm going to spend quite a bit of time talking around the subject about some of the background to this as well before we move into some of the details about the work we've been doing in Scotland. I just really want to put this into context. We're talking about climate change here. Climate change changes everything, absolutely everything. Meeting the sort of Paris Agreement around trying to achieve a 1.5 degree world is going to require really significant social, economic and cultural changes. This is not just minor change we're talking about. Reducing carbon emissions by 80% is a phenomenal task and will not be easy to achieve. So if we meet the goal of 1.5, well, we're going to get significant change. If we don't meet it and the world temperatures rise, we're going to get significant change anyway. So whichever way we're looking at it, this is about change. And I think the other kind of key point in terms of the context that I want to point out is we've done quite a lot in terms of science about helping understand the problem and possibly even identifying solutions. Where we're not very good at is how do we put these solutions into practice? The know-how, the doing is a real challenge. So holding that into context, what I'm going to talk about is a little bit about a range of different things, but I will draw quite heavily on a recent project that we've just completed. In fact, the reports are available today now on the website, and this is a project funded by the Joseph Rowntree Foundation in collaboration with a whole range of other collaborators, primarily with Dundee and the Scottish Borders Council, where we did some work. So I'll be drawing on that as we go along. The key messages, though, that I really want to get across today are when we're talking about engagement, you need to know what you're engaging for, you need to know who you're engaging with, you need to design for whatever it is that you're trying to do and whoever you're trying to work with. And really the other key point is, well, kind of fairly obvious, but this, engagement is a complex social process. It's not easy to do, and we have to account for that in the way in which we work. So, the first point really, engagement for what? Well, we've kind of heard already today about all sorts of different elements of flood risk management. Are we talking about engagement for better informed decisions or better informed action by the public? Are we talking about developing and managing kind of resilience groups that draw on the capacity and the ability of communities and others to engage in flooding? Is it about engagement to enact wider changes, for example, wider catchment management and farmers? We're hearing about that already. Or is it about engaging with policymakers and so on, about creating the enabling conditions for these wider changes to occur? So there's lots of different reasons and elements of why we might want to engage. But what's really critical, though, is our underlying assumptions that influence how we go about thinking about what we might be trying to achieve. And I'm going to talk through a couple of these kind of assumptions. The first assumption is, what do we think the origins of the cause of vulnerability actually is? Are we talking about the cause of vulnerability primarily from a hazard, so the strength, the speed, or the frequency? Or are we talking about the social, economic, and cultural conditions that affect vulnerability of the communities we're talking about? This is a little village called Runaga, and it's in the southeastern area of the Solomon Islands, where I've done quite a lot of work in the past. It's a very, very poor village. There's no roads, there's no electricity, there's really no financial markets. It's very difficult for people to make money. It's quite exposed. There's not much space for food gardens. They rely very heavily on their subsistence kind of resources from the sea and from the forests. It's a tough place to live. And what we find there is that there are lots of underlying conditions that affect the vulnerability of communities to things like cyclones or extreme weather events. Rainfall, geez, they have 6 meters of rain there a year, every year. Rainfall is a big thing, but it washes away food gardens, which are really critical for people. And what we found really in the work that we've done there, and this is a very simplified kind of story of the Solomon Islands kind of issues, and that there's a set of underlying conditions and dynamics that really create that vulnerability. So I'm going to give you a quick story. It's quick. Basically what we've got in villages like this, an increase in number of people. It's affecting the pressure on the ecological systems. There's not enough space for food gardens and so on. It's increasing stress in communities. They try and make money to address that problem. The way they make money is try and plant cash crops. The cash crops then displace their food gardens onto less fertile, steep-sided slopes, highly prone to landslides and so on, so that increases the pressure. As you get more money in, you kind of get a desire for more money because people they want more material goods. It does some positive things, like it increases access to health and education. They can get to the local clinic easier and so on. But it also kind of tends to move towards individualistic attitude. So in the past, people would come and help somebody build a house. Now they would want money for it. So the social cohesion in these communities breaking down, their ability to come together to address problems is decreasing. That increases stress and so on. So there's this complex set of dynamics, and what that really means is that if we want to address these kind of problems, we often think about income generation in these communities as a way forward, finding ways of doing that. But that kind of drives the system. It drives this system of planting more cash crops and so on. It doesn't necessarily alleviate the problems. So there's these kind of underlying conditions of increasing stress. You can see the spiraling kind of pattern of change that's occurring in these places. And what we find is that the vulnerability from this comes from these underlying dynamics. So if you add climate change onto that, where it's harder to plant the crops and so on, or you get more extreme cyclones, it's this underlying change and pattern of conditions that really give rise to the vulnerability. These short-term shocks are kind of important. Of course they're important, but they're less important in the long run than these underlying kind of conditions of stress. So that's really critical. So when we're talking about engagement, are we talking about engagement for addressing these underlying causes, or are we talking about engagement for addressing the kind of immediate hazards? For most of these people, the odd cyclone is not in their picture of kind of problems. It's much more fundamental and deeper kind of than that. In terms of the work we've done in the Scottish borders, we worked in 3 communities, and I'll come to that later on. But one of the kind of key things, we're seeing similar patterns of dynamics of things that are happening there as well. I'm not going to go into the details, it's a bit too complicated, the story, but essentially you can imagine all these kind of complicated relationships between the different things that affect who is disadvantaged by climate change in a more general sense. And what we find is that the longer term stresses that affect the ability of households to balance their budgets are as important, if not more important, than the shocks from the flooding in itself. So these kind of underlying conditions where it's very, very difficult to, if you haven't got much money and you're having to make decisions about whether you eat or you heat your home, eat or heat in those kind of conditions, some elderly people in those conditions in some of these communities, then it's really, that's what you're going to focus on. So when you get changes from climate change like increasing food prices, that's going to have a longer term, slower stress effect on those underlying conditions as well. And that will then create the kind of critical thresholds at the point in which a flooding comes in and has a further impact on you. It's kind of similar to the sort of story you're talking about. When we're talking about the sort of disadvantaged groups, there are these underlying stresses that are combining and pulling together. They can't afford then the insurance to cover that and so on. And those are probably more important often than the shock themselves as well. And the other thing that comes out of it is that community capacity is really important. One of the counterintuitive things that comes out of flooding is that when you get a flood, lots of people come together. They then learn a lot more about who is vulnerable in their community, and that kind of reduces the stress for those who are vulnerable in long term as well. So there's kind of a set of counterintuitive things that are happening there. So working on community capacity, so engaging people in that space is really, really important too. And I think just really finally, just to point out and draw that out a little bit further, is this question of, well, what is a disaster? So there's a recent work by a PhD student of ours, Jade Patterson, who did some work in Jamaica. It's just passed a PhD examination now, and she was working with communities in Kingston. Lots of kind of effects from things like landslides and flooding and so on. And when she asked people, what are the kind of disasters that affect you? They say, it's the drug raids. They completely wipe us out. So when the police come into their homes, they basically take away people's livelihoods. That is their disaster. It's not flooding. Yes, the flooding comes every now and again, but these are the bigger disasters for them. So I think it's really important to widen up the perspective and start thinking in a much more holistic way about the people that we're talking about that are affected. It's much more than flooding. I think really then what we're talking about, if we go back in terms of what we're talking about, what are we trying to engage for? We're talking about the shocks, the flooding. These are changing over time with climate change. The stresses are changing. The socioeconomic technologies and so on that are in society are also changing. And change is changing. So in the Solomon Islands, they talked about, they recognized that when we're asking about what has changed, they say, change is changing. It's getting faster. It's getting faster. This is, I don't know if you know this, the Great Acceleration. If you're just about whatever kind of variable you look at globally in terms of what's happening. In the last 50-odd years, there's been a massive increase. Paper production, water use, world population, carbon dioxide, surface temperature. These are all exponential growth. We're entering this period of great acceleration. So all of this is happening. And one of the things we tend to think when we focus on with climate change, we tend to focus on, let's predict what the hazard will be doing in 50 years. Well, the social conditions are going to be completely different in 50 years as well, right? So we have to be thinking about this in a much more kind of integrated and holistic way. So what does this mean then? Engagement for what? When we start talking to communities, they're talking about these multiple benefits, multiple issues that they're dealing with. Emergency management tends to focus on the now, on the immediate, on the flood itself, and so they're mostly talking about efficiencies, how can we do that better and quicker. Flood risk management is somewhere in between, but often we're talking in this kind of space, we're not talking about really what communities are trying to deal with in this wider kind of perspective of what we're dealing with. So is it about engagement for this kind of thing, or is it about engagement for this? And that really matters. So that's really the point I'm making there. Now, the second assumption that often we forget is when we talk about engagement, there are lots of different ways of thinking about engagement, right? So one of the kind of traditional ways of engaging or thinking about it, particularly comes out of the international development and the development work, is about participation. How do we get a wider range of people involved in doing whatever it is we want to do? This is an example really from the 1960s and 70s. The whole notion of participation was a move away from the style of top-down development that was coming out in the 60s and 70s internationally. And really this is an example of that. The Green Revolution in the 1960s and 70s, they were having to import huge amounts of food. Basically, there wasn't food in there. So they set up a whole process of science and technology, bringing them into villages and enhanced efficiencies in agricultural productions and so on. So, okay, great, fantastic. And it worked fairly well. You know, no imports of grains in 1976 to 80. But at the same time, there was an increase in extreme poverty, and there was an increase in landlessness. Extreme poverty, 38 to 53%, 20 to 50%. So really the point there was that this top-down process of let's put these technologies in place was, yes, it was increasing the food, but what was happening is it was mostly increasing the capacity of those who already had capacity or resources. So the wealthier farmers got the technologies and built that, allowed them to buy land from the poor that couldn't afford to do that. So it really failed. It really failed to raise up the population, and it actually increased inequalities. So really participation then was this notion, well, we need to work more with those disadvantaged groups. We need to find out what they need, and we need to find different ways of operating. So our assumption then about participation, what is participation, how do we engage, is really, really critical. And the key point really is participation about achieving a particular end? Is it about achieving a better flood defence? Or is it about something about learning capacity empowerment to raise up the status of those who are most disadvantaged in communities in the first place? And that's really the key point. If you're thinking about participation because I want to build a better flood defence scheme, okay, fantastic, and it might make it more efficient. This notion of participation as a means to achieve something. I'm going to engage with community groups to achieve a better flood scheme. That's fine, but it's less likely to focus on this capacity building, the alternative approaches, the multi-solving kind of ideas. You're more likely to engage in drawing out more ideas from different people. It may result less in continued motivation for engagement because you're not asking people really genuinely for their opinions about how they want to do it. Or is participation as an end in itself? Is it a process of empowerment where you go in and say, okay, let's talk about flooding, but let's keep a wider perspective and open about what is possible in terms of natural flood management, or how we tie that in with economic challenges you're dealing with, or how we tie that in with addressing disadvantage issues and so on in communities. So it's how we think about that concept of engagement, what we're trying to achieve by it is really, really critical. So the key messages, as I've gone through, we've covered this, know what you're engaging for. Well, who are you engaging with? In the Scottish Borders Council, we identified some key groups that were likely to be most affected by climate change, particularly around flooding. So elderly people with existing health issues, people on low incomes, local businesses, tenants, essential infrastructure users, families with young children, those kind of groups. These are the ones, again, that are less likely to be able to afford insurance, for example. So, okay, you might want to work with those kind of groups. But often what we forget is if this is a wider part of process of learning, engagement, capacity building, opening up spaces for addressing inequalities, then it probably requires us to be part of that process too. We have to be equal participants in that process of learning and rethinking our assumptions about what might be important. And that's really critical. So how do you then develop engagement strategies that are going to bring in local council people to think about it, or other organisations that might be working in there, to be part of a co-learning and co-creation of the solutions to the challenges that people are facing? And that's really critical as well. So that's the engagement with who. What I'm going to start doing now is just going to briefly kind of go into an explanation of the Scottish Borders project that we worked in, give you a bit of a flavour of how we kind of went about designing some of that, and just talk you through that a little bit. I'm not going to be able to go into too much detail about it, but just give you a bit of a flavour of some of those sort of things that are going on.
You've got 5 minutes to do it.
Okay, that's great, thanks. So, Scottish Borders, right, we're going to run out of time, but it's okay, no worries. So in the Scottish Borders, we worked in 3 communities, all flood risk communities, and were affected by the storms in 2015. Peebles and Hoyk got flooded, Newcastleton, people were evacuated. The focus of the design really was this looking at climate change in a broader sense. We were using flooding to get in there. We were also looking at climate disadvantage as a lens into it. We put a lot of emphasis on flexibility and structure, and it was very much about building conversations and relationships. It was a social process that we were engaging with. So it's about convening spaces for that. Multiple outcomes we were looking for. I'm not going to go into these in too much detail. Tangible. Could we build a flood resilience group out of the work? Capacity building. Can we enhance relationships? Learning. How can we share perspectives and understanding around that? The engagement was really critical. It focused. Esther Carman was our project officer. She was embedded between the university team. She was actually embedded in the Scottish Borders Council, working with the council. And then we used a kind of multiple set of processes for engaging out with different people using various snowball effects and so on. The key thing is we use a structure, and it was a fairly empty structure initially, to have a set of convening spaces, workshops where we brought community together, looked at futures kind of oriented things and tried to think about developing kind of actions around that. Lots of work in between to kind of engage people and bring them into that. And then finally there's a policy kind of level workshop that tried to look at how we could improve the policy kind of level scope of the challenges in there as well. So that was the kind of the process of engagement that we involved. Lots of more detail around that, obviously, and you can have a look at the reports as we come into that. But I think the kind of key outcomes of really points that I want to make is that community resilience is a really complex social process. So these kind of diagrams, these are the metaphor. We ask people for their metaphors of what they thought their engagement was in. And you come up with all these different kind of metaphors, subjective kind of experiences of people involved in it. So some were patient passengers kind of standing there watching, being part of the bus journey, watching it go around the houses as it kind of people were trying to make decisions about what to do, and then kind of observed that. This was another one about forming groups as a person who was feeling that they were kind of on their own, trying to kind of follow this map. Other people came along with different interests, but again, in the end, they started to follow the map together and started to move forward. Another one here, just down the bottom, all aboard, lots of people coming into a boat, initially paddling in different directions, and then going round in a bit of circles, and then coming together as they realised that other communities were dealing with the same sort of thing. So this kind of just realised that this is kind of a complex social process where people are going to experience this in very, very different ways, and not always positively either. So it's a complex social process involving negotiations of power and control. It can contribute to greater shared understanding of goals. It requires time to be developed and sustained. So there's a kind of whole set of things that are coming out there that sort of demonstrate this is not something easy to do. And it takes time to start building those relationships to then allow you that capacity to take things forward in the long term. Lots of kind of design elements that you might think about. I'm not going to go through them all, but really this one was really key. Facilitation and participation expertise. We always think about the expertise, the technical expertise we need for doing a flood risk management or something like that. We hardly ever think about, we actually need expertise and people who are experts in gathering people together and working through complex challenges, working with different values, working with different perspectives. That's really difficult. It's not easy, and it requires a lot of time and effort. We put tons of time into doing kind of assessments of various vulnerability and so on. We often don't put the time into this, and that's really, really critical. And then finally, it's working with lots of tensions. Here's a whole list of tensions. You know, is it about trying to achieve a degree of holism, a wider perspective, or achieving a particular specific outcome? Is it about quick wins versus a long-term change? Is it about about participation, lots of people involved in that process, seeing that as part of the process, or having a very specific direction? Is it about data collection versus action? Is it about independence from outsiders or being embedded inside? There's a whole kind of set of different tensions in there, and that has to be managed, what we call a dilemma dance. It's kind of, you've got these two extremes. You put holism at this end and focus at this end. Somehow you've got to find a middle ground, because there will never be something that's completely obvious about what you might be doing. So it's always going to have tensions, and all of this needs to be kind of carefully managed and integrated and so on in various different ways. It's not easy. It's not easy. Anybody who's trying to change anybody to do anything, my wife, just getting her to make sure that the windows are closed when we put the heating on, it's a nightmare, right? So imagine that. And that's tiny compared to all this sort of stuff. So let's not forget that it's complex. So conclusions. I think we really need to be starting with people. That's what we're talking about. Systems, approaches, we're starting to see that come out with these multi-solution kind of ideas, but we need to engage with futures. We need to engage with creativity, imagination. We need to bring in the different expertise that's available in the room in various different guises. Farmers are experts of their own farming. Local people are experts of their own lives. These are really, really critical. We need to flatten that base and start working in that way. Engagement is a complex, messy social process, and we need this expertise. The reality is, though, that this is really difficult. There's not a lot of resources. Shouting for more resources is not really going to help. We've got to find some different ways of working in this. I don't have the solutions. However, the potential opportunities arise from exactly what I'm saying, which is partnership working, seeing things in a wider picture, making those relationships work. It's also about holistic and integrated solutions. You find the solution by taking the wider, bigger picture. And we're seeing that already from some of the things that have been talked about. If you open that space, those solutions will come. And then finally, I think it's about more integrated policy landscapes and for things like capacity building. We're not doing that very well. We're not linking the Community Empowerment Act with the Flood Management Act, for example, or the Climate Change Act. We need to start thinking about these things in integrated ways, and we need to be doing much more of that. Thank you very much.
Thank you very much indeed. That gives us a different perspective, bringing in not so much let's invite the community in, let's actually think about how communities react. Is this working? Yeah. Okay, questions please for any one or all of the speakers. Yes, Tom. In the middle here. Fourth row back.
Yeah, question perhaps primarily for Edmund. Tom Letherland. You mentioned the idea of when flood risk or flood prevention measures are put in, then insurance premiums go down for that small area. But we also saw that the proportion of area, potentially flood-prone areas where measures are getting put in is actually a small proportion of the total, and at the same time I have a suspicion that if climate change is happening, which I believe it is, then the likelihood of flooding occurring somewhere must be actually increasing, and I would have thought that percentage increase was probably as much as the small decrease that you're getting where you have put in a flood prevention measure.
All right, I understand the question. You're saying that the change in risk outweighs the investment expenditure in that locality. Well, that may be the case, but it's poor. It's a poor message to give the people who have invested in that particular scheme to see their insurance premiums not fall. And in the meantime, before your increased risk occurs, the money still goes into the shareholders' pockets because the costs of insurance are less, but the income is the same. I'm repentant about that.
Okay, lady at the back, please.
This is a question for Michael. I'm just wondering, in some communities they have some active community groups that kind of help broker the messages from the flood warning and really help galvanise action in the community. Did you look at the role of any community support groups in kind of translating and brokering sort of information and action?
That was one of the questions we asked in the questionnaire. Are you part of a flood group? I don't have the response in terms of did that mean there was a more effective response, but that will be something we're looking at. So good question. Thank you.
Then the gentleman 2 rows down. Thank you.
Hi, Conor Price. I'd like to query Edmund in relation to his understanding of the insurance industry and what level of flood risk they would consider to be acceptable. So, for example, I would assume that the 1 in 10-year flood event would be of concern to them. I understand that the 1 in 75 is often considered the threshold, but is the flood industry or the insurance industry concerned about the 1 in 200 or the 1 in 500 year level of flood? And from the perspective of a flood protection scheme, is there a level that we should be targeting when you consider the opposite side of that equation?
I think the insurance industry, well, the industry as a whole is concerned about major events, because those are the events that could lead it to be insolvent. And therefore, the government requires the insurance industry to be able to meet the costs of a 1 in 200 year event. That's the regulator's approach to it. Whether they are concerned more about the 10-year flood than the 50-year flood, I don't know, actually. Because you have 5 times more 10-year floods than the 50-year floods. So I'm not sure that it doesn't even out in some sort of way. I haven't heard of any differentiation between different return periods and industry concern. Only about that top one of 200, where they must meet the regulators to have sufficient financial resources in the bank, if you were, to be able to meet the 200-year event.
Are we getting tired? No, you've had a shot. And James is gone, so he doesn't get another shot.
What question would James have asked?
How do you pay the farmers for being stewards? Anyway, but I'm not getting into that area. Yeah, and I'd like to ask you, this very crucial area of engaging with or getting the communities on board. One of the things I find when, a bunch of old men, who are my neighbours, which includes me, think, the river's going to flood because there's high water and there's a storm surge, and they all know the answer. I've got a totally different answer for them, of course, because I'm a geographer, but how do you deal with these really set views in these debates when you've got that sort of polarity, and they're saying, well, what do you know about it anyway? You're just an academic from the unreal world.
I think that's a really good question in which there's no easy answers. But the way I've approached it is that you try and create spaces where it's a co-learning. And that's the only thing you can do. And the only way to do that is to go into that space on the assumption that you need to be one of those learners as well. And really, that's the only way to do it. And there are lots of different ways of creating those spaces. But it does really come back to, as I said, having that expertise in participation and facilitation, which is really, really critical. And having people who really understand the processes that are involved in that. And one of the key requirements of those kind of people is that they have to be independent of that process. So it's kind of seeing yourself as the project that we ran in the Scottish Borders. I did quite a bit of the facilitation participation, but that was challenging because I wasn't really independent. I still had, a report to write out of it and things like that, so you're dependent on certain outcomes, and that can be challenging as well. And it requires time, and it requires patience, and it requires different kinds of ways of approaching it. One of the things that, as I said, the flooding did impact on the communities while we were working there. And that completely changed the extent to which people obviously engaged in our project, not surprisingly. In Hoyk, we had a workshop that was already set up. It turned out to be 5 days, I think 6, 7, 8 days after the flooding, which was phenomenal. So suddenly we had a pile of people coming into a space that had really, really strong perspectives and views. But we used a particular method which helped us give them time to talk about the challenges that were dealing with. Flood insurance was coming up a lot. We had a method then that allowed us to then separate that from their wider aspirations of what they wanted to achieve from the town. And the interesting thing, when you start talking about the present, they're talking about flooding. When they talk about the future, they're talking about urban regeneration in Hawick. So there's a real difference. And so what we then were able to use is that space to talk about how, if we were, well, there's a design of a flood scheme coming in, how can we change that design to help achieve the future they wanted, not just to address the flooding. So you can find commonality once you've agreed on the problem, and that is often the way forward. Yeah.
Yes, Chris.
Thanks, Chris Spray. It's perhaps a sort of comment on what Johan's just said. If I go back a few years when I was wearing a SEPA head and look at a different part of Scottish Borders Council, and different part of that area, rather, we had a major problem with flood issues, and between ourselves as SEPA and the Borders Council, the only body that actually could go in was a total independent trusted intermediary, which in this case is Tweed Forum. They were able to go places to have conversations that even if we had all the structural skills we might have learnt in academia, there's not a chance in hell we could have had it, because we came with all the baggage. They actually could walk away and walk in without having to achieve a result, in a sense. You know, it's a very different one. So that was a scenario that, as I say, came out of a fairly dramatic event. It's probably about 15 years ago, so I've almost recovered from it.
Yeah, I think, Chris, just briefly, I think that's true. I think what we were trying to do in the Borders project is actually create the spaces where you develop those relationships so you didn't have to be in that situation in the future. And that's where you need the longevity, because you start building those partnerships, those relationships on a basis of trust. It's much, much easier to then continue that. The challenge of our project, it was 18 months, so we'd really only just got started by the time the project ended. And that's one of the challenges. How do you continue to do that kind of work when councils don't have the resources to work in 3 communities? They've got to work in 60 communities. And they just don't have the staff to do that. Yeah.
Gary.
Question for Michael. You set out a very sort of clear explanation on the improvements of flood warning that had taken place in Scotland over the past decade or so. But if we pick up on Edmund's point that we're moving to a world where people have more choices, and one of the choices might be sort of real-time flood insurance, where you click a button and say, I want insurance for next week. I mean, how far are we away from getting that quality of prediction into our flood warning systems?
Good question. I think it depends. Obviously, a number of the flood warning capabilities and forecasting capabilities are quite advanced now. I think I've presented the case in the last 10 years. It's not the case with surface water forecasting. Clearly, there is still a lot of uncertainty around that, so there's still a lot more challenges to go before you would be able to put that action in place based on all that. So, yeah, depends.
It's interesting. Warnings are really problematic. I like the quotation from your Scottish policeman. I mean, I've talked to people about the 2007 flood in England, and they say, we were never warned. We were never warned. And yet the television every night was going bang, 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 all the time. Oh, yeah, but nobody knocked on our door. So the warning that they wanted was personal, not just the television. And that's the problem that your policeman had.
Yeah, I mean, that's clear from a lot of the evidence that's come back through the research is warnings need to be more local, more relevant, more applicable to the individual. Now, clearly that could be possible in a lot of cases where there's a lot of data and information and forecasts to provide that to the communities. Where there isn't, you've got that gap. And particularly with the flood alerts, things like that, they are too broad, they're not relevant enough for the people that receive them, and that's all they get.
But can I follow that up? You know, we've all got mobile phones, we get these warnings. But there are groups in our society, I mean, you flag those up, the elderly particularly, who don't have that facility. Mm-hmm. You know, how do we make sure that they're not made even more vulnerable in these situations because they don't have access to this?
Yeah, yeah.
And there's no telephone directory of mobile phone numbers like there is on landline numbers. If you want to find the landline number, if somebody who lives in number Smith Street, you can find it. You can't find the mobile number.
I think when you mention the more elderly, when we look at the demographics of the people who've responded, it's actually at the higher end of the age categories that have responded in terms of the flood warning service. Those between 18 and 30, less inclined to engage with the floodline service, flood warning service. They're more difficult to engage with in terms of signing up and taking action.
Last question. Just a question, please, not a speech.
I'll be brief, promise. Miguel Piedra from Arop.
Sorry, I thought it was that guy. Yeah, sorry, I still not seen that. I didn't mean that comment to you, sir.
I forgive you. A question for Mike and for Ian. It's more a thought, but I will phrase it as a question to try and prompt discussion. To what extent improving community resilience, community engagement, the second type of community build-up you explained, and also the advancement in flood warning will reduce the need for real hard defenses and investment on defenses, which we seem to run out of money and not being able to keep up with?
Well, obviously you can see from the figures that clearly people are taking action in terms of property level resilience measures. People are responding to the warnings. So that message getting out there. I think there was a Scottish Government survey or research a couple of years ago about how effective they could be on a community scale. So it's worth referring to that piece of research in terms of the benefits wider across a community rather than at an individual level. So yes, I think there are potential benefits there. It does lead to requirement for effective flood warning, an engagement on a local level and make sure it's locally specific to them. If you want to.
Yeah, I mean, there's no easy answer to that, but I think there are it's obviously part of the solution, but you have to be thinking about solutions in a much wider perspective. There will always need support, but there are also some really significant capacities I don't think have been tapped into yet, and it kind of, you have to start thinking about a shift in who has ownership of the problem and who has responsibility for the problem as well. So there is potential. But it's how that's enacted, I think, that's really critical. And the way to enact it is to see it in a wider picture.
Final question. Just a question. No, you can't because of the recording system.
Thank you. And I'm in the habit of giving speeches, but I won't do it this time. The question about how do you engage with old people, infirm people in the community. In the Edinburgh floods some years ago, which I was involved in, we introduced the concept of neighbourhood flood watch. Not neighbourhood watch, but neighbourhood flood watch. And the neighbourhood flood watch scheme worked because neighbours knew who the vulnerable were, they listened to the radio and so on, and they engaged with their community to try and prevent it. And I'd just like to say, it is a speech actually, I'd just like to say the social dimension of flooding is the most important dimension of flooding. And that is what we really have to work on. I'm not being negative about the amount of research we do into climate change, etc., but we should spend a bit of time in the social dimension. Thank you.
Thank you very much. Well, I'd like you all to thank our three speakers who have done us proud for the last speaking session of this meeting. Thank you all. Thank you. Now don't you close the doors now, because Gary Pender and I are going to tell you what today's all been about. See if you've been at the same meeting as he and I have. And Gary's going to kick off, I think.
I'll kick off, yeah. So thank you, Roger. I mean, I've had an absolutely fantastic day. I think everybody else, or I hope everybody else has as well. The speakers have done us proud. One of the things that's really struck me is the sort of coherence and the seamless movement from one talk to the other. You would almost think it had been planned by the organising committee. It has been a long day, so I'll try not to take too long, but I do feel I should give a sort of summary of the kind of scientific aspects of what we've heard about today. We started off with Chris Kilsby, who spoke to us about the challenge of finding trends in extreme events, whether stationarity was dead or in fact undead, and the fact that even surprise events were sort of unsurprising. So light-hearted touch, but certainly some very important scientific insights into the statistics of flood extremes. We then moved on to Nick Reynard, who also gave a very interesting talk on the work that CEH have been doing on global climate modelling, downscaling that to a catchment scale, using the catchment characteristics to sort of rebuild things up, to discover that different catchments across the UK had different characteristics and would respond differently to climate change, and then coming at it from a very practical perspective and investigating whether the 20% additionality that we have been using for climate change was appropriate, and reached the conclusion that for different catchments we needed different percentages of additionality, and that would be somewhere between 20 and 40% depending on the catchment characteristics. So really practical outcomes from some very detailed research and detailed and difficult computer simulation. Next we had Hayley Fowler, who spoke to us about the challenges of simulating convection storms and how you had to use really refined grids to capture the physical processes that were taking place within these cells that are, relatively small scale to some of the things we think about in terms of flooding, but can have significant impacts and cause significant floods because the rainfall's intensities associated with them are really quite high. So again, really high quality, difficult science that's having a real impact in what we do as far as flood management is concerned. Then we moved on to Mark McLaughlin from SEPA, who updated us in SEPA's flood mapping and how these maps could be used. Very practical, honest approach from Mark on the use of maps with and without flood defences included in them, what SEPA could do to enhance their flood mapping in future, and that sort of approach they had to continually upgrading the quality of data that we in Scotland have available to us. I was particularly interested to hear about I think it was FedCap, the app to collect real-time data during floods. I think that's a really fantastic initiative to use up-to-date technology to feed in to improve flood modelling. As a flood modeller myself, data is the absolute key to trying to improve these things. So, very, very important. After lunch, we started with David Bamforth. David, being an engineer, very down-to-earth approach. He told us that water flows downhill, and when it stops, it forms puddles. I didn't know that, actually. That's something new I learned today, but that's fantastic. But joking aside, excellent summary of sustainable urban drainage techniques that we can use in the urban environment, ranging from multiple uses of infrastructure during flooding, insights into what they're doing in the Netherlands with no subsurface drainage in some of the estates, adverse cambers, and trying to control the water on the surface, and then the example about river realignment, combining both water management with amenity value and social enhancement. So I thought these were all excellent examples that we can learn from and implement. Then we had the sort of mirror image of that presentation from Mark Wilkinson on natural flood management here in Scotland, and the work that the James Hutton Institute have been doing on retention ponds, buffer strips. Mark actually also mentioned sediment and erosion and the problems we can have with sediment in some of these systems. I particularly thought the example on the James Hutton, is it a research farm or something that you own up there, but the idea that you break the land drains, you allow the water to flow through a bioactive root zone into buffer strips at the edge of the field, and not only does it have benefits to flooding, but it also helps you manage it. The nitrate runoff from the farmland was particularly interesting and another good example. We then had Mike. I knew that was a difficult question, Mike, actually. I just thought I'd test you out there at the end, but Mike gave us a very succinct update of how far we've moved forward in flood forecasting here in Scotland over the past few years or so, and it was really interesting to hear about that, the percentages and overall satisfaction, the way in which people's behaviour has changed as a consequence of these enhanced warnings was all interesting to hear about, and how the key to this is actually trying to motivate people to take the right decisions in light of uncertainty associated with climate and with rainfall was also a useful learning point. Edmund, as always, gave us a fantastic insight into the insurance industry, the role of the insurance industry in flood risk management, how the overall robustness of the industry is important to us, the pain threshold, which was a new term to me, but makes absolute sense when you hear about it, how areas of deprivation here in Scotland mean there's higher pain thresholds in these particular areas, and then an insight into what the future of flood might be and how we might have to think about how that's going to transition in the future was also useful to hear about. It was also good to hear that people in Scotland actually have a higher annual income than people elsewhere in the UK, although he stopped short of making any comments on why that might be politically, which I think is probably quite a sensible thing to do when you're speaking in Scotland, Edmund. And finally, Ewan talked to us about the complex social processes associated with taking some of these decisions in flood risk management and how you motivate people and how you need to think about social interaction actually as a system rather than a sort of thing, and the whole difficulty around discussing these things with people, how they need to be able to run meetings appropriately and not just think about the technical aspects, was absolutely critical, and he left us with the thought about if we want this to be successful, we've got to think about learning capacity and how we actually empower people, which I thought was a really good message to hold in our minds as we moved on. So these were the key points I took from today's meeting. As I said, I've had a fantastic time. I've really enjoyed every presentation. I hope you have too. And I'll pass back to you, Roger.
Yeah, very good. Well, I've learnt a lot as well, which is really good. People of my age always think we know all the answers, and it's what really pleased me today is not just listening to the speakers, but to see the age structure of the audience. It's so good to have so many young people here. And when I look at the list, I see that you're in engineering companies, you're in statutory agencies like SEPA and SNH, and in local authorities, as well as the universities. And that's just the audience that we're looking to capture with these events in the RSE with our various partners. I was struck this morning, somebody said too much focus on scientific assessment and not enough on practical solutions. I mean, it strikes me with a foot in both camps, if you like, that it's very important that we have the scientific underpinning, recognising all its uncertainties. Scientists are really good at telling us what the uncertainties are, but there are some head points that come out. But there are some known knowns in these things, not just that water flows downhill as well. And how far can we use and translate that evidence that we are gathering all the time through these amazing multidisciplinary studies in many universities in Britain, translate that evidence into the practical flood risk reduction and management. If I had my headlines for the public, thinking forward to our next session and thinking forward to what we want to put in our advice paper, which will go to all the MSPs and everybody else who wants to listen and we hope might listen. First is the scientific bit. Flooding's been with us for generations, and I think that's a really powerful message. We tend to think that we've had more events, and I think it was a salutary lesson in analysis of data over long time series this morning. And the present trends are actually consistent with that much longer time series. But at the same time, there are clearly predictions of more extreme precipitation events. And with that, extremes are a lot of uncertainties attached to it. So there's no simple answer. What I think has come out beautifully today in all of the case studies that have been presented is how we deal with the spatial variation of the data and the putting in of management solutions. And it's something we sometimes forget in Scotland. Scotland is not a level playing field in addressing these matters, and it's okay to have an Act of Parliament and a statement from whatever government's in place and its agencies, but unless we recognise that spatial variability in the phenomenon, but also in the people who live in those areas with all of their diversity of socioeconomic circumstances. We're not going to get anywhere. The next point is that if we're going to live with flooding, and this is a very dangerous statement to make, because of the uncertainty of connecting the flood point with climate change in any convincing way, and given all of the people on the right wing of this argument, of which, and I'll be perfectly blunt, there are rather a lot of them and are very vocal, getting over the message to the public that this is all to do with climate change, as opposed to lousy upland management, poor planning in urban areas. I leave that with you to reflect. You can hammer me afterwards if you like, but let's try and think how we get these messages over. Next, well, it's pretty important that everybody gets insurance. I think the clear message there is that, well, Flood Ray is perhaps not working because it's not hitting those elements of the population which are already intensely deprived on every other socioeconomic indicator. And that's, I think, a very important one for our society to make that clear to government when it's looking at these issues. Next, well, it's identifying where the problems are. And I think it's really superb, the work that SEPA has been leading on with a whole lot of experts, of looking at the spatially specific data collection and its use on flood risk. David knows that I've been very critical of the old SEPA maps. I looked at them before I bought my house and rang up the insurance brokers. Now we've got a much more sophisticated data collection system for inland and at the coast. And I think that's vitally important that, you know, we, the public, support the continuation of that work and make sure that the government doesn't pull the plug on it in times of austerity. And we have now got the development of excellent flood warning systems. Let's make sure that all of the people we would like to sign up for those warning systems and that we make them as available and as amenable to the customers as possible. It's really good this survey has been done. I congratulate you on that. And finally, we have to keep demanding the connected solutions to these sorts of issues. I still find, as a former civil servant, that there is a government which is very good at operating in silos. And we need to make sure that we've got the connected solutions, because we know from what we've heard today is that the connected solutions are not just about flooding and flood risk management. They're about giving a whole lot of other multiple benefits, which people on the ground really appreciate. And we've got wonderful examples we've heard today, natural flood management and what I'd like to call nature-inspired engineering solutions as well, in rural areas and in urban areas, on intensively managed land and on land which is, let's face it, probably overbuilt on and over-engineered in terms of overland flows. And finally, this importance of meaningful engagement of all the stakeholders. The people that can cause the problems, like the planners. I don't think I've heard the word planners mentioned today, and building control people. They are very significant in this, as are the farmers and the wrong signals from the Common Agricultural Policy, which hasn't been heard much about today, but that's very, very important indeed. Obviously the affected households wherever they are. So I hope you've all taken some really good material back to wherever you're working, back into society. Thank you all for coming. I'd particularly like to thank our sponsors, If I had the piece of paper, I'd be able to read them out. Yeah, Gary's got it here. John Hutton Institute, Scottish Government, Scottish Natural Heritage and SEPA coming together, which is extremely important to get that strength of support. I'm really grateful to all of my fellow chairs, to the organising committee. We worked on this for many months, and I hope you, as the audience, recognise how valuable this is to you. Thank you all so much for coming, but we haven't finished yet, because not only have we got a public engagement session later on, we will be producing an advice paper with our speakers, and then we're also hoping to publish the papers, if the speakers produce them in a reasonable time, hint, hint, in the Scottish Geographical Journal, which is available to the 2,000 members of that society for free and to any others. So we've not finished, because these meetings are all about getting messages out to wider community. And before I finish, I'd like on all your behalves, all of our behalves, to thank the guy who's led all of this, Alan Werrity, for driving it forward. So thank you all very much.